27. That is we have explored from the internet. That is some of the list of the movie which we have the historical background from 1927. Metropolis in 1932. That is the Der Heider Welt, that is based on the Germany, and so on. You can see a lot of AI based movies here. So they are based on the AI techniques. Alan Turing in 1936, that is, he told in the research paper that is the machine can think and mimic like a humans. So this concept is given by the Alan Turing in 1936, but you can see the movie started from 1927. You can see that is we have a movie which is based on we have collected from the internet sources the top 5 movie which is basically based based on the AI, and they have the various category, that is for the emotional feedback, that is the healthcare feedback, or you can the safety purpose and so on. So we have to see, you can see here, that is the movie which is based on the
AI or artificial intelligence is becoming a major buzzword in recent years. Knowing what it is and its practical applications in real life in the upcoming future leaves us stunned. Although movies tend to exaggerate AI for dramatic effect, there is still some truth in these movies. There are AI experts who fear a super intelligent AI could outsmart us and eventually decide to wipe us off the face of the earth. On the flip side, AI is depicted as a miracle invention. These intelligent machines can perform analytical tasks such as simulations and predictions much better than humans. So if you're interested in AI, you should check out our top 5 AI movies list that you should never miss watching in life. But before we begin, if you're new here and AI or artificial intelligence is becoming. On the flip side, AI and predictions much better than humans. So if you're interested in AI, you should check out our top 5 AI movies list that you should never miss watching in life. Examples of an AI movie. It covers all the bases, allowing the protagonist to be a proxy for the audience to explore AI's moral arguments, whilst also deploying a thriller narrative arc to hook the audience in. The film follows the story of a programmer who is allowed to be a part of an experiment to evaluate the capabilities of a highly advanced humanoid called Ava by his CEO. He is the first person to meet Ava, and his goal will be to test whether Ava passes the Turing test. What happens next carries the storyline forward and captivates the viewers in the process. The movie focuses on how we interact with AI as humans and how a machine could in turn manipulate humans. This movie is phenomenal and a definite do not miss. At number 4, we have the 1968 sci-fi classic 2001: A Space Odyssey. This movie is perhaps the most intricate and ambiguous movie on our list. The Stanley Kubrick masterpiece revolves around time, space, human nature, and evolution, and the film is narrated in a non-linear direction with inexplicable cuts to different contexts. The film opens millions of years ago in a desert with apes discovering a giant black monolith. Under its influence, the apes then begin using bones as weapons. Then the film transitions to a space voyage to find the origins of a mysterious monolith in the far reaches of the galaxy. The spaceship functions are controlled by an artificial intelligence computer named HAL, which claims to be foolproof and incapable of making errors. However, during their space mission, the ship's crew gets double-crossed by HAL. When the error-free HAL makes an odd error, the astronauts decide to disconnect it from the ship's controls. But HAL, however, discovers their plan and goes rogue, killing most of the crew. Next, we have Metropolis, ranked at number 3. Metropolis is a 1927 German film, and undoubtedly this movie served to be a pioneer for many AI-related movies. Metropolis depicts a future world where the wealthy people of the society live in ease and luxury on the surface. In contrast, deep down in the city's underground, Working class people labor out of sight on the machinery that supports metropolis. In time, this oppressive situation eventually leads to a class conflict. Freda Frierson, being a member of the wealthy class, falls in love with a working class woman named Maria. He also discovers the grim scene under the city and is determined to help the workers. To sabotage his plan and his relationship with Maria, Freda's father and a scientist create a robot in Maria's image. Within the context of the film, the robot Maria seems to have its own mind that causes rebellion within the working class and eventually attempts to destroy Metropolis. With the massive popularity of Metropolis, the robot Maria stands as the first significant robot in the film industry. And for the first film attempt at AI, the storyline is absolutely incredible. It raises interesting moral questions about the possible human likeness of AI-based robotic creations. Moving ahead, we have Her at number 2. This movie highlights emotional intelligence in the form of human-robot romance. This movie reveals the direction humanity might be headed if artificial intelligence continues to evolve. The main lead of the film doesn't know what he wants from life and people after being pushed to the verge of divorce. His life takes an unexpected turn when he begins to find peace in the voice of his computer's new operating system, Samantha. The heartfelt conversations with the AI system Samantha makes him fall in love with her. Despite its advanced setting, the idea of this movie is alarmingly genuine and therein lies its brilliance. Given our dependence on innovation, AI voice assistants, and virtual realities, we may soon witness relationships between devices. They are engaging, entertaining, yet sad. Last on our list is Pixar's masterpieces and one of the thought-provoking movies, Wall-E. Wall-E is an excellent contrast to other AI killer robots shown in films. Wall-E is the last solar-charged robot left on Earth. He spends his days tidying up the mess the humans created before leaving the planet Earth, one piece of garbage at a time. Yet, during 700 years, Wall-E has developed a character, and he's terribly sad at being alone. Then at that point, he spots Eve, a smooth and more advanced AI bot sent back to Earth on a scanning mission to find any existence of life, ignoring Wall-E entirely as he was a robot. Smitten, Wall-E embarks on his most incredible adventure and follows Eve across the galaxy and along the Milky Way. Wall-E can't even talk, but his characteristics and mannerisms resemble human behaviors. Another significant aspect is that Wall-E tells a story where AI saves humanity rather than destroying it. This is interesting as it shows a sense of dependency and the needs of AI for creating a better future.
So, have you seen these 5 movies, which is based on the different arena of the applications? So, how AI is important for our lives and so on. It has started from the 1927. So, these are the some applications where we can apply the artificial intelligence, and we have already these concepts beginning from the 1927 and so on. So now let us see the term we are using the artificial intelligence, machine learning, and as well as the one concept is deep learning. So how they are associated. So basically AI is the big umbrella which comes under two things, the subset, that is machine learning and the deep learning. So let us see how to differentiate it. In the artificial intelligence, that is the engineering of making intelligent machines and programs in the artificial. While in the machine learning, you can see that is the ability to learn without being explicitly programmed. That is, we are learning from the data. Okay. In the deep learning, we have the learning based on deep neural network, which is like as our human brain have. So these are the some basic difference between the artificial intelligence, machine learning algorithms, and the deep learning algorithms. So deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence, as just we have discussed. But what are the actual similarities and differences between them? A common way of illustrating how they are related is as a set of concentric circles with AI on the outside and deep learning at the center, as it is depicted in the Venn diagram you have seen. In this way, you can say that the artificial intelligence is the larger overarching concept creating machines which simulate human intelligence and the thinking. On the other hand, you can see machine learning is a practical application of artificial intelligence that is currently possible being of the limited memory. By and large, you can say machine learning is still relatively straightforward with the majority of machine learning algorithms having only one or two layers, okay, such as an input layer and output layer with few, if any, processing layers in between. But you can see the machine learning models are able to improve over time but often need some human guidance and the retraining. In contrast, you can say that deep learning has multiple layers. In the machine learning, we have two layers, input and output layers and their program concept, but in the deep learning, we have the multiple layers like as our brains. And it's these extra hidden layers of processing that gives the deep learning its name. Deep learning algorithms are essentially basically self-training in that they are able to analyze their own predictions and results to evaluate and judge their accuracy over time. The time passed, the machine becomes more intelligent. Deep learning algorithms are capable of independent learning. So DL is able to do this through the layered algorithms that together make up what's referred to an artificial neural network. So these are the inspired by the neural networks of the human brain, but obviously fall far short of achieving that level of sophistication. That is, they are significantly more advanced than simpler machine learning models. And our most advanced AI system, we are currently capable of building the system. Now, the artificial intelligence is the simulation of human intelligence. What we are doing in the artificial intelligence, that is the simulation of the human intelligence, which is processed by the machines, especially the computer system, you can say. So a specific application of AI include like expert system, you can say natural language processing, speech recognition and machine vision. So how does AI work? As the hype around AI has accelerated, vendors have been scrambling to promote how their products and services use UI. So AI has a very vast application in different domain of applications like agriculture, healthcare, automation and so on. AI requires a foundation of specialized hardware and software for within the training machine learning algorithms. Now we are using the many programming language which is the synonym for the artificial or machine learning algorithms, that is you can say Python, R, Java or SQL and so on. So many languages are available. But Python is more popular for the machine learning algorithms. You can use machine learning algorithms in the Google Colab and so on. Okay, that is the freely available for some type of memory and so on. In general, AI systems work by ingesting large amounts of labeled training data, analyze the data for correlation and patterns, and using these patterns to make the prediction about the future states. In this way, you can say a chatbot that is fed examples of test chats can learn to produce lifelike exchange with people, or you can say image recognition tool can learn to identify the described objects in images by reviewing billion of examples. That is one of the example is Google Lens. You are using these concepts. AI programming focus on three cognitive skills, that is the learning, reasoning and the self-corrections. So the learning process of the aspect is focused on the acquiring data and creating rules for how to turn the data into the actionable information. The rule, which is called the algorithm, provide computing devices step-by-step instructions for how to complete the specific task. Now the reasoning process, this aspect of AI programming focus on choosing the right algorithm to reach the desired outcome, because one algorithm is not sufficient for the other application. So we have to choose the right application or the right algorithm for the right applications. Now the third one is the self-correction process. This aspect of AI programming is designed to continually fine-tune the algorithms and ensure they provide the most accurate result as much as possible. So that is the self-correction. As the time passes, the machine becoming more intelligent and so on. acquiring the past data and the informations. But have you thought about the different dimensions of the science, that is mathematics, statistics, data sets, data analysis, optimization, algorithms and data mining. Artificial intelligence and machine learning algorithms, they are using these all the concepts in their algorithms. You can see that is the Google Assistant. Okay Google, if you ask from the Google, okay Google, that is what is the machine learning algorithms, we got the answer, that is machine learning is the scientific study of algorithms and statistical models that computer system use to effectively perform a specific task without using explicit instruction, relying on models and inference instead. So this is the definition I have taken from the Google search using the word okay Google. Okay. In the same way, when we ask from the Wikipedia, from the Google Assistants, we got the definition of the machine learning is as you can see. That is, machine learning is the scientific study of algorithm and statistical models that computer system use to effectively perform a specific task without using explicit instruction and relying on the models and inference instead. It is seen a subset of artificial intelligence. So machine learning algorithms build a mathematical model of a simple data which is known as the training data in order to make predictions or decisions without being explicitly programmed to perform the given task. So machine learning algorithms are used in the application of email filtering. We are using that is spam detection and so on, detection of network intruders and computer vision, where it is infeasible to develop an algorithm of a specific instruction to perform the task. So what we are seeing the email filtering, it is through the machine learning and AI techniques. Machine learning is closely related to the computational statistics, which focus on making predictions using the computers. So this type of mathematical optimization delivers method, theory and application domains to the field of machine learning is known as the machine learning and AI. Data mining is also a subfield of the machine learning algorithms, which focus on the exploratory data analysis through the unsupervised learning. So these are the some concepts of the machine learning. So how machine learning algorithm works? You can see that is it is based on the previous or historical data. So normally what we did, that is data gathering, storage of the data from the data that is you can store on the data warehouse. Then you can pre-process, means the cleaning of the data, because most of the data are the are not perfect, or some noise is there, or that is not relevant to your application. So you have to clean these. That part is known as the data pre-processing. After that you have to choose the model, means that is one model is not appropriate for the other applications. So you have to apply the model for your applications, which choose the best. Here you have to apply the optimization technique as well, right? Then you have to train the model, that is in the machine you have to train that model. You have to train the model, and then after training the model you just test the model, that is it is properly working or not. If there is some error, then you tune the model and you will get the predictions. So that is the way how to process of the machine learning is involved in the systems. So in simple terms you can say that is in the machine learning algorithms we are using the historical data to make the future predictions, building models on historical data for the predictions, taking training data, building models on the training data, using the models to make the future predictions, and make the machine learn the patterns in the data and give the better predictions. Okay, so you can apply the optimization technique, and other advanced optimization tools are available, and you can apply during the building of the models or the training of the models. So we are getting the data in the different form. We are getting data from the various devices, IoT devices, and so on. So we are getting that is the numerical data, image data, which is in the form of pixel intensities, video data, which is in the form of frames per second. We are getting the data from sound data, that is in the form of waves and so on. Test data, we are getting the various tweets, comments, feedback, and so on. There is some problem, I think. I am audible to all of you. Hello? Hello? Hello?
Sir, sir.
I'm audible?
Yeah, sir. Yeah. Yes, sir. Yeah. You are audible, sir.
Okay.
You are audible, sir.
Okay. I am again because slides are not moving, so I am again. I am again sharing. Please hold. Is it clear? Hello?
Sir.
I'm audible?
Yeah, you are
Okay,
audible and
slides
screen
are
is visible, sir.
okay, fine. So we have to see that is the learning system model, how machine learning learned from the systems. That is, we have the input sample, then that is here the system. That is for the testing phase and for the training phase, and we'll apply the learning method and we'll get the predictions and so on. Now there are, you can see the training and testing phase, how it works. Here is the data acquisition, that is a universal set of unobserved data, and we have to training set, that is we have to classify the data in the different clusters and so on. Then we have to train the data, test the data, and we'll get the unobserved data. So these are the training and testing phase of the data. We have to apply the various algorithm for this. So training is the process of making the system able to learn. So no free lunch rule is applied here. That is, training set and testing set come from the same distribution and need to make some assumptions or bias nets and so on. So what we have done, that is for the universal set, that as clubbed in the various clusters are there, but here we have to categorize the data and we are getting uh, uh, the data on the different domains. So there are several factors affecting the performance of the systems, that is types of training provided, the form and extent of any initial background knowledge, type of feedback provided, learning algorithms used. So these are the some factors which gives the performance of the systems, or you can say that is the performance of the system is depend on these four factors. So there are two important factors which is mainly contributing the things, that is modeling and the optimization. So that is, there are three types of machine learning algorithms which we are using, that is the supervised learning, unsupervised learning, and reinforcement learning. In the supervised learning, data sets are labeled so that the patterns can be detected and used to label a new data set. On the other side, you can see that in unsupervised learning, data sets are not labeled and are sorted accordingly to similarities or the differences. And the third one is, that is the reinforcement learning. That is, data sets are not labeled, but after performing an action or several actions, the AI system is given feedback. So here in the reinforcement learning, we are giving the feedback so that it gives the better predictions. And in the supervised learning, we are getting the labeled data, and in the unsupervised learning, the data are not labeled. We have to label for the processing. So you can see that is the 4 categorization is there, that is machine learning problems. That is the supervised, we have the classification and regression, and in the form of the unsupervised, you can see that is the clustering and dimensionality reduction. So these are the examples and the algorithm for the machine learning problems. Let us see how clustering is strategy is working for the machine learning problems. That is the k-means. K-means means that is the clustering is a method of vector quantization that aims to participation of p-n observation into the clay clusters. That's why here we are using the word k, in which each observation belongs to the cluster with the nearest means. Okay, the cluster centers are the cluster centroid serving a prototype for the clusters. Original form of signal processing, it will be reassign point to the nearest cluster center. This is the k-means algorithm, you can see. Now the next one is the agglomerative clustering. This is a bottom-up approach. In this approach, each of the observation starts in its own cluster and pair of clusters are merged as one moves up the hierarchy. So start with each point as its own cluster and it will be merge the closest cluster, that is the agglomerative clustering. Now the next one is the mean shift clustering. Mean shift clustering is, that is mean shift is a non-parametric feature. You can see that is a space analysis technique for locating the maximum of density function and so on, or called mode seeking algorithm, that is the estimate modes and so on. So these are the 3 clustering strategies, that is k-means clustering, agglomerative and mean shift clustering. Now another one is the spectral clustering, that is in multivariate statistics and the clustering of the data, spectral clustering techniques is used, okay, for the data to perform the dimensionality reduction before clustering a fewer dimensions, like as the image processing and so on. So split the in this clustering, split the nodes in a graph based on assign the links with the similar weights. Now next one is the classification. Classification. So you can see that is the, for the classification we have taken that is the prediction function for the feature representation of the image to get the desired output. So here you can see fx equal to y. So x here is the function is the, that is the set of apples. So we can categorize each as an apple. Here is the tomato, so we can categorize as tomato. Here is the cow, so it is can be categorized as the cow. So these are the prediction function of the feature representation. So you can see here that is y equal to function of x. So here y is the output, f is the prediction function, and x is the image feature as we have already defined in the image. So here training, given a training set of labeled examples, here we have the x1 y1, x2 y2, x3 y3 and so on, xn by an estimate of the prediction function by minimizing the prediction error on the training set. So we have to minimize the number of errors and apply f for a neighbor before seeing test example x and output the predicted value of y equal to function of, that is on the testing phase. So in the next step you can see what we have processed, that is the training image. We have training image, then image features, then training labels and training and learn the models. And for the testing phase you can see test image, image features, learned model and the prediction. So these are the algorithmic pattern how the training and testing can be done on the machine learning models. This is an example, or you can say that is the steps. So here you can see that is the for the image form we are getting the raw pixels, histogram, geometry description and so on. Now let us see the classifier. So classifier, we are taking the nearest neighborhood, that is the, we have the training examples, you can see here, that is fx equal to label of the training examples for the nearest 2x. So all we need to a distance function for our inputs. So how it works, we need a distance function for our inputs and no training is required in this form. Okay, so that is the example. So let us see what is the classifier in the machine learning. Okay, so a classifier is nothing but a machine learning algorithm that automatically orders or categorizes data into one or more of set of classes. So that is known as the classifier. One of the most common example is an email classifier that scans email to filter them by the class label. That is the email is spam or not, or that can be done by the classifier which Google is using. Machine learning algorithms are helpful to automate tasks that previously had to be done manually. Okay, so they can save huge amounts of time and money and make business more efficient for the future. Ventures are the same ventures. So what is the difference between classifier and model? A classifier is the algorithm itself. Okay, a classifier is the algorithm itself, which rules used by the machine to classify the data. A classification model, on the other hand, is the end result of your classifier machine learning. Right? So the model is trained using the classifier so that the model ultimately classify your data. So that is the basic difference between the classifier and the that is the model, you can say. There are both supervised and unsupervised classifier. Unsupervised machine learning classifier are fed only unlabeled data set, which they classify accordingly to pattern recognition or structures and anomalies in the data. While in the supervised and semi-supervised classifier are fed training data set from which they learn to classify data accordingly to the predetermined categories. So sentiment analysis is an example of the supervised machine learning algorithm, where classifiers are trained to analyze test for opinion polarity and output the next into the class. That is the positive, neutral or negative and so on. So try out this pre-trained sentiment analysis model to see how it works. You can see here. This is the linear function to separate the class. This is, so here we are using the classifier signum function, fx equal to signum of w dot x plus b. So how to categorize the classifier in the linear classifier? So many classifiers exist, that is support vector machine, you can say neural networks, naive Bayesian networks, logistic regression, randomized forest, boosted decision trees, k nearest neighbor and so on. There are so many, but which classifier is best for the application? So no classifier is best. It depends upon your application, it depends upon your problem, which classifier suit well for your application. So you cannot say that is which one is the best. That is depend upon the application and depend upon the application which you can apply for your problems. Now let us see an example for the recognition task and supervision. Here you can say this is the motorbike or not. How the your machine learning algorithms understand this is the bike or not, and it recognize the face of the bike. So it basically it contains a motorbike and it has different attributes. You can see, and this can be defined in the machine learning algorithms, and after that that can be identified. If map on that model, then it classify that is the bike, otherwise it's not bike. So that is the algorithm. So you can see that is the we have the some examples of the supervised, unsupervised or weakly supervised or fully supervised algorithms. So here unsupervised means we have the collection of the various elements, but they are not categorized. Okay, they are not organized in the same way. So that is unsupervised. And here some parts is that is, you can see that is humans are categorized here, but here animals are categorized, here bikes are cars are categorized, but it is not defined which car or which animals are there. So it, you can say that is the semi supervised term or the weakly supervised term here you can use. Here you can see that is the, here each and everything is categorized, that is here is the car and this one is the animals, and that is the man and so on. So it depends upon the that is the task that is supervised and the unsupervised. You can see the generalization of another examples, that is that is, you can see here training set, that is the labels are known here, you can see all the labels are known, but here test set, you can, that is the categorized in the labels are unknown, you can see here. So these are the some examples of the trainings and the test sets. So here training and test have the biasness. In the statistical term we have the biasness. So let us see how it can be, how can we define the bias and variance trade-off. Okay, so that is the, basically you can say in the simple way, that is the error. So bias, how much the average model over the training set differ from the true model. True model means that is the standard model, you can say. So how what are the differences, or what are the errors, you can say, that is known as the biasness. So error due to inaccurate, it may be it may be due to some other reasons, it may be the inaccurate assumption, that is it may be the due to inaccurate data or inaccurate algorithms and so on. Anything can be. In the same way, that is variance means how much model estimated from different training sets and differ from each other. That is known as the variance. So here we are getting, that is underfitting and overfitting terms. Means model is too simple. Underfitting means model is too simple to represent all the relevant class characteristics. So if there is high biasness, then it comes to the low variance, and if high training error, then a high test error. So that is the underfitting conditions. And for the overfitting, model is too complex. Like as underfitting, model is too simple. For the overfitting, it is model is too simple and fits irrelevant characteristic, that is noise and so on, irrelevant data and so on. So here you will see low bias and high variance, and low training error and the high test error. These are the some properties of the underfitting and the overfitting. So let us see the bias variance trade-off. That is here we have taken the example. In the bias variance trade-off, you can see model with too few parameters are inaccurate because of large biasness. That is, there is not enough flexibility in the model. Okay, and in the other hand, models with too many parameters are inaccurate because of the large variance. Means there is too much sensitivity to the sample. So that is the known as the example, that is bias and variance trade-off. It can be mathematically defined, that is the bias variance trade-off, that is mean square error, that is E equal to noise square plus bias square plus variance. So you can see that is the example, that this noise error is an unavoidable error, and this bias is error due to the incorrect assumptions, and variance is error due to the variance of training samples. So these formula is very useful for the finding the error in the machine learning models. You can see that I have taken from some books these slides. So you can see that I have given the reference as well. What happening, I don't know. Now next one is the bias variance trade-off. That is here we have taken, that is the complexity and error graph. You can see that is the training error and the test error. So that comes the underfitting and it comes the overfitting, which is obvious in the nature. You can see in the graph. In the same way, that is high bias low variance graph can be seen in the slides. That's many training examples, few training examples. That is the one of the bias variance trade-off example for the high bias and low variance. Next one is that is the fixed prediction model and the generalization of error. So these are the effect of training of size. That is for the time voice and variance trade-off. So we have taken here error and the number of training of examples. So you can see the graph how the testing phase grows on and the training phase with respect to training phase. So as we have already discussed that no classifier is inherently better than any other. You need to make assumptions to generalize your classifier. So in this way you can say that that is the pretty sure that is the classifier is basically useful when you learn the problem and their probable solution, how they work on. So you can apply the classifier accordingly for your machine learning algorithms. There are three kinds of error we can get, that is the which is inherent, that is unavoidable, that is which comes from the source as, so you cannot avoid that error. Biasness means that is the due to oversimplification. You can keep all the assumptions in your model. So it becomes the complexity will increase, and that comes in the biasness, because you can get some of the parameters are not useful for the model, but you have taken, that is the biasness. And variance due to inability to perfectly estimate the parameters from the limited data source. So that is the known as the variance, as I have already discussed in the previous slides. So these are the three kinds of errors. Now let us see how to reduce that variance and errors. That is, we have three techniques. First one, that is choose a simple classifier, then regularize the parameter and get more training data sets. So you can increase the data sets, you can reduce the variance. You can regularize the parameter, you can reduce the variance, and you have to choose the simpler classifier, so that you can improve your machine learning models and so on. So in this way you can reduce the variance. Now let us see the generative and discriminative classifiers. Okay, generative models represent both data and the labels, which often makes use of the conditional independent priors. So that is, the examples are naive-Bayes classifier and Bayesian networks. In this model, that is, models of data may apply to the future prediction problem. And the discriminative model means learn to directly predict the label from the data. Okay, and often assume the simple boundary, that is linear regression and so on. You can logistic regression, support vector machine, boosted decision tree. These come on the discriminative models. Often easier to predict label from the data than the model on the data. So let us see about the classification. That is, we have to see what is the classification. Means you have to assign input vector to one of two or more classes. Okay, so any decision rule divides input space into the decision region 1, region 2, region 3 and so on. So separate by the decision boundary. So you can see here we have the three boundaries, that is region 1, region 2 and region 3 in the examples. So next one is the nearest neighbor classifier. You can see that is Voronoi partitioning algorithm is here given for the image classifications. So you can see assign label of the nearest training data point to each data point. So here these are the dotted are the Voronoi partitioning we can see. Now in the k nearest neighbor means you have to select the you can see that is the data is, you can see. So here the attributes are collecting, making the you can see that is the block accordingly cluster. You can see that is the nearest neighbor. So this is known as the three nearest neighbor, or the five. Here we have the 5 blocks, the 5 nearest neighbor and so on. So if you have the k, so it becomes the k nearest neighbor. So using k nearest neighbor, simple we have already discussed. So you can see the logistic regression, how it can be identified. That is, as we have taken from the previous examples, that is a male and female. So it can be categorized. We have the margins of the pitch of the voice and the height. We can categorize the class, that is which one is the male or the female. So here what we have taken, that is the we have taken that is the well-known formula for the weighted values, that is px1 x2 y equal to 1, and this one. So this is the log linear model, it is known as. So you can apply and you can get the answer as a predicted value. So here we can see the L1 and L2 regularization. So here you can see in the same way you have the classifier, that is linear support vector machine classifier. Here we are using signum function w dot x plus b, that is which is a very well known classifier, as you have seen in the previous slides. We have also discussed about this classifier. So this is the linear function to separate the class. This is very useful. This is the margin, how to identify the that is to separate the class. So we have the non-linear support vector machines, that is data set which are linearly separable and work out for the grade. That is example. If the data is too hard, you can see this is for the higher dimensional space. You can map on the dimensions and so on. This is just example. Now we are taking the functions, that is kernel functions, that is which is very useful to map one functions or one area to the another area. It is known as the kernel function, like as a signum functions we have taken. So a function that takes as its input vectors in the original space and returns the dot product on the vectors is the feature space, is called the kernel function. That is the basic mathematical definition of the kernel functions. Okay, so here what we are doing, we have to define, that is linear algebra is here making a great role to how to identify how to map the function from one dimension to the another dimensions. So here you can see those who are the mathematics students, they can early identify the things how it can work out. So you can see that is we have the data xz, which is the real number, and map from one function phi to that is in the real number phi x to the real number. Then it can be defined at kxz equal to phi x phi z. That is the inner product of those functions phi x and phi z. It's a kernel function which identify that is it should multiply, it should obey the Mercer's theorem. Means that is the phi dot x phi x dot phi z should be 0. So this function, kernel function, this theory, Mercer's theory, is very important for the kernel function, and we are using this function, that is very well known idea. You can see that is the kernel tree. That is, here is the input space phi x, and this is the another function, and we are applying the Mercer's theorem here, or the kernel function theorem will get the feature space. In the same way, we can apply the non-linear support vector machines. You can see that is here we are applying the another function, and we are getting the higher dimensional feature space where training set is separable. Here training set is not separable, but here when applying we are getting the training set is separable. So you can see that is kernel functions, as we have already discussed about the Mercer's conditions or Mercer's theorem, phi x I dot phi x j equal to 0. This is the nonlinear decision boundary features, which is a well-known function. This is the mapping function from one dimension to the another dimensions. You can phi x dot phi x square by square, after multiplying using the linear algebra property, we will get kxy equal to xy plus x square plus y square. If the Mercer conditions hold, then you can map the function, otherwise we can't map the functions. These are the some generalized Gaussian kernel or intersection kernel functions, which is very obvious in nature. These are the another functions for the Gaussian kernel. So summary, you can see the support mechanism for image classification is pick an image representation, okay, then pick a kernel function for the representation, then compute the matrix of kernel values between every pair of training examples, then feed the kernel matrix into your favorite support vector machine solver or classifier, you can say, to obtain support vectors and their weightage. At test time, compute kernel values for your test example and each support vector and combine them with the learned weights to get the value of the decision functions. So this is the basically algorithm how to classify the image using the support vector machine. So these are the some steps. So you can apply these steps, you can get the decision function, okay, or the prediction values. We can apply multi-class that is function, but unfortunately there is no need. Here we have the various learning objective which is used for the for the kernelization. For the naive based algorithm, this is the learning objective. This one is the training. This is the inference. So here we have collected from the various resources which is written, that is available freely. Now we are using two norms also for the that is the L1 norm and L2 norm for the regression. So that is known as the ridge regression and the lasso regressions. So ridge regression and lasso regressions are two different techniques for increasing the robustness against the collinearity of ordinary least square regression. Okay, both of these algorithms attempt to minimize a cost function. The value of these two regression is ridge regression and lasso regression is minimize the cost functions. So you can have you can apply this regression for the better result or better predictive result. The cost is a function of two terms. One, the residual sum of square. Residual means that is the, you can see that is the errors. Okay, sum of square, errors of squares taken from the ordinary least squares. The other an additional regularized penalty. So the second term is an L2 norm in a ridge regression, and that is the another L1 is the lasso regressions. So you can see the mathematical observation of these two regression is that is ordinary least square. We solve the minimized following cost function. You can apply this cost function, cost equal to y minus x beta transpose of y minus x beta cos opt equal to this one. So this term is that is the residual sum of square, RSS we can say, and the ridge regression, that is we can use the cos of this function. Okay, so these are the term of the L1 and L2 norm. So in this way you can say regression analysis is a reliable method of identifying which variables have impact on the topic of interest. The process of performing a regression allows us to confidently determine which factors matter most, which factors can be ignored, and how these factors influence each other. So regression analysis is the most vital part of the machine learning algorithms. So regression is, in this way you can say regression is basically a statistical method using in the finance, investing, other discipline that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by equal to a plus bx, or even that is the linear regression, but you can apply for the exponential regression or the quadratic regression and so on as well. Okay, probably those who are the statistics or mathematics student, they must be aware about the regression analysis. Here we are using as a machine learning models. So things are same, but we are applying in the nature. It has machine learning and artificial intelligence have a vast application in the area of the business and finance as well, in the marketing as well. So we have a movie or an example. You can watch it and you can see how the hologram technology is which is based on the machine learning algorithm and the artificial intelligence technique, how it is useful for the next generation, and this technology exists. That is the important. Please have a look.
Here in Las Vegas to present to you. Now I get invited to do keynotes across the globe, and while it's easy for me to be here in Las Vegas, it isn't always easy for me to travel across the world. And even when I do, I can't always speak the local language. Well, what if neither language nor distance mattered for me to deliver a fantastic keynote? What if technology could help me be anywhere I needed to be and speak any language I wanted. Well, it can. We are bringing together the power of mixed reality and Azure AI services to create a truly game-changing experience. What you're about to see is an exact hologram of me wearing the same outfit that we recently captured at a mixed reality studio. And I don't speak Japanese, but what if I wanted to deliver my keynote in Japanese? Using Azure AI technology, I can translate my English into Japanese and train it to sound exactly like me. The same voice tones, those same inflections. Now we've brought this together, my hologram and Azure AI, to show you what's possible. So first, I'm gonna put on my HoloLens 2 here, and then we'll flip in the room to the special camera so you can see exactly what I'm seeing. Let's get started. First, let me introduce you to Mini-Me. There she is, my perfect holograph. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Render keynote. Now, as you can see, this is mind-blowing technology. And what you just saw was my life-size hologram, my exact replica, rendered here in real time, speaking Japanese with my unique voice signature. To do this, we use mixed reality technology to create my hologram and render it here live. Then we use Azure speech-to-text capability and English transcription to get my speech. Then use Azure Translate to get the speech into Japanese, and finally applied neural text-to-speech technology so it sounded exactly like me, just speaking Japanese. And the most amazing part? All of these technologies exist today. The future is here.
Hello.
Sir.
Hello.
Yes, sir.
Hello. So thank you. Have you seen this video how the AI technology and machine learning algorithms are important, how they are in the current scenario. Their immense scope is there. So thank you all for listening me. Now any questions from the audience?
Okay. Dear participant, you may ask if any question if you have any question you may ask to the respected resource person. Any question? Any query?
Hello, sir. My name is Sumit. Uh,
Okay.
sir, my question is that, sir, suppose that we have a set of apples with the and we have to recognize the which land is come. So it is possible in the machine learning.
What?
Dear
I'm not
participant, your
getting.
voice is breaking. Participant, your
Yeah.
voice is breaking.
I
You,
also said that,
you can repeat, please.
uh, sir, there is a number of apples from the different land, uh, production land. I might said, if I categorize the all the apples by the land,
I'm sorry to
can
interrupt.
we recognize by the machine learning?
Actually, दो
Sum,
devices पर उनको आ रही है.
Sumit, your voice is not audible properly. Can you send me email to you? I will give you the answer. Right? What your question? Can you repeat? I am not able to understand what you are asking
Sir, I
because your
mail you.
because your voice is not clear. That is there is noise in the voice.
You can send your question in a chat box.
Yes, yes. You can test.
Okay, if you have a question, you can text to me also. Okay, or mail. You can mail to sir also. He will provide the response on mail also. Okay. Actually, another resource person is waiting, so we have to end up this session, and we have to be ready for the next session. So let me thank Professor P.K. Misra sir for this very brainstorming session and for their valuable time on the session for the workshop. Uh, Sir have discussed a lot of things on fundamental of data sciences and machine learning, how machine learning works, what is artificial intelligence, what is deep learning, data sciences, and the machine learning framework, the spectrum of supervision, effect of training size, various kernel functions, different functions are used in machine learning. Thank you very much, P.K. Misra sir, for giving your valuable time and support. Thank you very much again, sir. Thank you, and
Thank you.
we are
Thank,
planning we
thank
are
you.
planning another workshop also. It is that you should be join us again in future, sir.
Okay, okay, thank you. Most welcome. I would like to thank to all the participants and the organizer for organizing such a beautiful event. Thank you very much to all. And my
Thank
greetings
you,
to all
sir.
of the participants as well.
Thank you. Thank you. Okay,
Thank you.
thank you, sir. Okay, now
Thank you.
Dr. Sundar sir has joined this workshop. He is a resource person for the second day lecture. Now I request Dr. Abhishek Bansal sir to introduce Dr. Harisankar Hota sir.
Shall I join?
Dr. Bansal sir.
Yeah, it start. Thank you, sir. I'm Dr. Abhishek Bansal, Assistant Professor, Indira Gandhi National Tribal University. Firstly, welcome to Professor Hota, sir. Now it is my privilege to introduce Dr. Harisankar Hota, sir. Harisankar Hota, sir, is a professor and head of the Department of Computer Science and Application, Atal Bihari Vajpayee University, Bilaspur, India. His specialization is in artificial intelligence, machine learning, soft computing, and decision support system. He is visited in various countries like Thailand, Mauritius. He has published more than 50 research papers in reputed journal, which is indexed in Scopus, Web of Science, and SCI. He delivered more than 25 international and national talks and organized more than 25 FTP programs. He he also uh, he also a reviewer of many reputed journals. He is a editor in chief for international journal. He awarded Best Paper Award in various international and national conference. So, sir, thank you very much for joining us. Now, I'll just invite Professor Hota sir for deliver lecture on real-time application of COVID and machine learning.
Okay, thank
Dr.
you,
Hota sir.
Dr. Abhishek. Can you listen me? Am I audible?
Yes, sir. Yes, sir. Yes, sir.
Okay.
You are audible.
Okay. So first of all, I'm very much thankful to the entire team of this international workshop being organized by
Thank you, sir.
Department of Computer Science of IGNTU, Amarkantak. Thanks to Dr. Vikas, the Dean and Head of the Computer Science, Dr. Pawan, Dr. Rathor, and their entire team for organizing this wonderful event. And I am fortunate that I'm the part of this international workshop. And just I'm going to deliver a small thing related to the theme of the workshop, the fundamental of machine learning and its application. The most of the things related to the fundamental of machine learning already explained by Dr. Misra from BHU. So he has made my task little easy. I'll concentrate more on the application of this machine learning in the different domains. These are the research work which we have done actually, and we have applied the machine learning and deep learning in the different domains that I will try to explain. So this will be a brainstorming session for all you people. So that you can just think where the machine learning techniques can be used and in what direction the machine learning techniques can be used. So we'll concentrate more on the application part, because as I said you, the basic algorithms of machine learning has been explained by Dr. Misra. Uh, if you want to do some work in machine learning and deep learning, you have to love mathematics, because the mathematics is very important in this, because algorithms are all based on the mathematics. So, because the pandemic is going on, this COVID-19 pandemic we are facing since March 2020. So, the most of the applications are based on COVID-19 pandemic. It is somehow related to the COVID-19 pandemic. During the lockdown, the first lockdown, we have worked a lot related to the different problems. We have tried to solve the different problems related to COVID-19 using the machine learning as well as deep learning. So the entire application is somehow near to the COVID-19 pandemic. We have tried to consider the different problems of the COVID-19 pandemic, and we have tried
Dear
to
sir,
solve
your
the problem.
slide is not visible. Dear Hoda sir,
Okay,
your
yeah,
slide is not
it's
visible.
visible
Okay,
now.
now, yes, yes, sir, yes, sir.
Yeah, yeah. So this COVID-19 pandemic, as we are knowing, and a little bit will try to explain about the artificial intelligence and how the COVID-19 is somehow related to the artificial intelligence and machine learning. And there is advanced algorithms that is known as deep learning nowadays, when we are having the high dimensionality data, when we are having different nature of data like image data, video surveillance data, and audio data. So for all this kind of data, the deep learning is most suitable. Instead of having the machine learning technique, the basic machine learning techniques, you can go with the deep learning technique. It provides the various advantages over the machine learning. But whenever you want to learn this machine learning, you have to learn the basic algorithm of the machine learning, like k nearest neighborhood algorithm, bias algorithm, regression technique, and all these you have to learn, and then you can switch to the deep learning. So that also I'll explain, and then at last we'll try to concentrate more on application of machine learning. So, friends, you are all facing the COVID-19 situation. Still, we are facing, and due to that COVID-19 pandemic only, we are like in the virtual platform, and this conference, this workshop is being organized in the virtual platform. And as you know, that this pandemic has taught a lot to all of us. This has changed our mindset also, our emotions also, our thought process also. The entire phenomena has been changed due to the COVID-19. And being a expert, being a students of, being a researcher of the computer science, always we have to think that how this problems of the COVID-19 can be solved using our tools and technique, that is artificial intelligence and machine learning, that we have to think. So let us raise a question in your mind, that can AI and ML will provide solution for COVID-19? If you raise this question, the answer will be, obviously it will be yes. There are different kind of problem, that is contactless service you have to provide in the hospital. So how the contactless service can be provided? So that is what possible with the help of the artificial intelligence and machine learning. This the situation almost in all the countries. So we have the challenges and we have the opportunities also. And this, as I said, you this pandemic has opened new doors for everyone. Being a researcher, it has opened the new doors. We can go with the problem, we can identify the problems of the pandemic, and then we can try to solve the problems. So, being a researcher, this COVID-19 has opened the new doors for every computer science persons and every researcher. So, this what actually artificial intelligence and ML, it has already been explained by the Professor Misra. That's artificial intelligence. It's a discipline of computer science where we are studying about the development of intelligent system. The intelligent system, because the most intelligent person is what, that is a human being is the most intelligent nowadays. And how we can develop a system which will think very similar to a computer, intelligent system. That is what that study is, what artificial intelligence. There is a new terminology emerged nowadays, that is XAI, that is explainable AI. Because in machine learning and artificial intelligence, what we are doing, we are putting the data, the algorithms are there, so that algorithm evolves some like output, produces the output. So that is what the like black box kind of things are there. So now we have the explainable AI. So what is being done, how the output has been achieved, that will be explained by the explainable AI. So that is another like area which has emerged recently. So artificial intelligence and explainable AI are the two things where we study about the development of an intelligent system which will think, which will behave very similar to the human being. And machine learning, that allows the computers to learn and make the computer intelligent on the basis of the historical data, on the basis of the past data. And artificial neural network, as you might be knowing, that it is inspired by the human brain. Our thought process, our thinking process is entirely based on the biological neural network. That the huge and complicated biological neural networks are present. Neurons are present in our body, and they takes the decision. They send the electrochemical signal, and that electrochemical signal is being processed by the biological neuron, and then certain decision has to be taken by the biological neural network. So it is inspired, this artificial neural network is totally inspired by the biological neural network, which is a type of machine learning, in fact. And now we are talking about the deep learning techniques, where which is basically used for the like complex kind of problem, like machine vision and object detection kind of things are there. So that kind of problem can be solved using the machine learning. These are the two very popular deep learning algorithms are there, that is convolutional neural network and LSTM. So these are the pyramid. You can think about this pyramid, that we have the artificial intelligence, machine learning, artificial neural network, deep
खाना खाना
learning,
होगा ना तुमको
and the like algorithm of deep learning. So there you may be confused that what actually artificial intelligence, how they are correlated with each other. So this diagram will make you clear a little bit that artificial intelligence, just you can think that artificial
धीरे धीरे
intelligence
अब
is a
तुम्हारा
set.
वो हो जाएगा,
It's a
हाथ बढ़
set.
जाएगा.
Somebody is talking. Raghav Prasad is talking, perhaps. So please. So that's just you can think that artificial intelligence is a set. Okay. If you go inside that set, you'll find another set, which is a subset of artificial intelligence. You can see that machine learning is a subset of artificial intelligence. If you go inside of the subset of machine learning, you'll get artificial neural network as a subset. So just you can think that artificial neural network are the algorithms, tools, and technique under the machine learning. So it's a subset of machine learning. And if you go inside that subset of artificial neural network, you'll find that deep learning is what subset of artificial neural network. It's a kind of artificial neural network. So there are many definitions of machine learning, and I'm not going to explain all these things because it is already available in the literature. So the most important definition given by the Mitchell, a computer program is set to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. So just you can imagine that experience are not nothing, it's a data, historical data. Okay. And if you think about the email classification as spam email and non-spam email, then just you can have the data, that email data, that is your experience, and the task is what that is to classify the email as spam email and non-spam email. Performance P, that whenever you are going to measure, or whenever you are going to check the performance of any model, machine learning model, you have to use some performance measures. So there are different performance measures are available, like classification accuracy, sensitivity, specificity, ROC curve, MAP, different kind of performance measures are available. So on the basis of these performance measures, you have to decide whether your model is working properly for a particular problem or not. Because that model means algorithm, the performance of the algorithm may vary from the problem to problem. Say for for example, one algorithm is working for one problem very well, but it will not work well for the other problem. So that is what performance measure. And when the performance measure, you have to improve the performance measure uh, by tuning your model and by feeding the data and by splitting your data. Anyhow, the performance measures should be increased. So when the performance measure is increased on the basis of historical data, on the basis of experience T for a particular task, that is what we can say that machine has been learned. So this is what the Tom Mitchell has said about the machine learning. So just you can see this diagram that as human being, we learns from the experience, we learns from our mother, our father, we learns from the different sources like different books, and from internet we learns, and we enhance our knowledge, we enhance our intelligence. See, the computer learns, computer follow the instruction. If you'll recall the traditional programming language, we write the program and the computer just follow the instruction written in the program. While in case of the machine learning, it learns from the data. So whatever the experiences you are getting, that is nothing, that is a data for the machine learning. So you must have the data. Data is one of the most important ingredients for the machine learning task. Okay. So in the machine learning, it learns from the data. So this is how we can distinguish the traditional programming with the machine learning programming. The traditional programming, what we do, we write a program and then we give the data, and the data and program works together and provides the output. So this is the case of the traditional programming. When we write a program in C, C++, and Java, this is the scenario. But when we talk about machine learning, the scenario is little different. You provide the data as well as the output also, when we are especially talking about the supervised learning. So the data will be there and the corresponding output will also be there, and it will evolve the programs. It will evolve the program. That is the most important aspect of the machine learning. So this just you can imagine how the traditional programming language is little different from the machine learning. Okay. See, this is already explained by the by Dr. Misra, that we have the three different types of machine learning: the supervised learning, unsupervised learning, and reinforcement learning. The very simple thing is that when we are talking about the supervised learning, the some supervisor is there. So, suppose you are learning something, yeah, and your teacher instructing you, and your teacher is teaching you in front of you, and your teacher is continuously observing you in during the learning process. That is what the supervised learning. So your supervisor is there. He or she is looking after your learning process. He is providing some kind of instruction to you, and then you are learning. So that is what the supervised learning. In the supervised learning, always you have the target data. Always you have the target data. So the supervised learning, when you have the input data as well as the target data, that is labeled class are there. That is what supervised learning. When we don't have this kind of data, that is what unsupervised learning. So how they will be classified, like on the basis of the features of the data, they will be clubbed together. They will create a cluster, and all the elements of all the objects in a particular cluster will be similar with each other. More or less they will be similar with each other, while the object, if you compare the object of one cluster with another cluster, they are what dissimilar in the nature. The reinforcement learning, here also you don't have the like labeled class or output data, and on the basis of the feedback, it learns from the feedback, in fact. So these are the three different categories of data, and this slide has been shown by the Dr. Misra, that we have the two different categories of data. That is discrete data. The discrete data is what that like suppose you have the gender, then male and female are kind of discrete data. And the continuous data, which is what if you are saying like 5, 10, 20, 30, like your stock forecasting data is like continuous data. So on the basis of the data available with you, this is the different task of the machine learning can be defined. So if you have the discrete data, and if you have the supervised learning, then the classification will be there. If it is not, then unsupervised discrete data and unsupervised learning, then clustering will be there. It will try to form the clusters of the similar kind of objects. And if you have the continuous data, and if you are applying the supervised learning, that is what that task is known as regression. And if it is unsupervised, it is known as dimensionality reduction. Okay. So this slides has already shown by the Dr. Misra, so I'm just skipping this one. So this this is the entire process of the machine learning. It doesn't mean that we have the labeled class or not. Suppose you have the image data, and the first thing is that whenever you are giving this data to the machine learning model, you have to extract the features from the image data. Like suppose these are the fruits and some animals are there, so you have to extract the features from this object, this image data. So the feature may be the color of the fruit, the size of the fruit, dimension of the fruit, hardness of the fruit. These are all features that you have to extract, and that features has to be given to the machine learning algorithm. And when you are providing the training labels, that is what the output data, if you are providing, that is a kind of supervised learning. And the outcome is what, that is a learned model. Okay. So this is what like iterative process. In fact, you have to develop a model which will perform well for your problem on the basis of the performance measure. So the outcome of this, the entire training process, is your learned model. That is your trained model, in fact. So once you have decided that yes, the model has been trained, now it is working well for your problem on the basis of, in fact, performance measures. Now that you can deploy that model, and just you can ask that model whether it is able to predict the things or not. So these are the data. This is the data, object data, that is unseen data. In fact, unseen data means what? The model has not experience with this data. Okay, so this is unseen data. The model is not seen it has not seen this particular data. So again, the same process you have to perform. You have to extract the features, and you have to give that data to the learned model, and the prediction will be there. So it will, suppose this is a classification process, so you have two different kind of data, two different classes of the data. One is the fruit, and there is the animal. So it will predict whether a particular object that you have given is fruit or animal. So that kind of classification may be there. So this is the same thing shown in the different way. You have the data, you have the feature vector, you have extract the feature and give it to the machine learning algorithm. And if you are talking about the supervised learning, you have to provide the labels also, that is the output data also. You have the outcome as predictive model, and then unseen data, the test data you give, again extract the feature, and then expected label or the prediction will be done. While in case of the unsupervised learning, you don't have, just you can see here, you don't have the label data, you don't have the corresponding output. Features will be given to the machine learning algorithm, the model will be developed, and then that model will be able to identify a particular class. So the very important thing is that whenever you are talking about the machine learning model, you have to think about the splitting of your data. You have universal set of data. Whether it doesn't mean whether you have collected the data from some repository, or you have generated the data, you have the universal set of data, and then you have to split the data in the training set and the testing set. Now this is there is no thumb rule, in fact, to split your data as training and testing set, but the more portion of the data should be in the training set and less should be in the testing set. So like suppose 100% data are splitted, like 80% you can keep for the training and 20% you can keep for the testing. So that is again a research problem, and you can split the data as 80-20, 85-15, 90-10, something like that, and just you can check the performance of your model. And if it is performing well with 90-10 ratio of the data, just you can go with that particular model. Okay, so when we are thinking about the artificial intelligence and machine learning, the data is very important for you, all of you. So where the data are available, so the data may be available in the repository, like UCI repository, Kaggle is there. So there are different repository sites are there from where you can get the data. So the data are nothing that your Twitter data or the data, your Facebook data, your student related data, the stock related data of your faces, your signature. These are all different kind of data, and that this data may be your in voice format, in your image format, in your video format, in your numeric data format. So there are different kind of data. You must have the data when you are talking about the machine learning techniques. The features, like in each data you have some features, like when you talk about the student name, gender, location, mobile number, these are all the features of that particular data. And the third ingredients is the method to train the models. So algorithms are there, so different algorithms are there, a lot of algorithms are there. In that algorithm, different parameters are there. So you have to understand the algorithm, you have to tune the parameters so that your model will perform very well. So these are all research problems. You can integrate one algorithm with another algorithm, you can assemble one algorithm with another algorithm. So that ultimate objective is to develop a robust and well-performing machine learning model for a particular problem. So you just remember these three things when you are talking about the machine learning: data, features, and algorithms. Okay. Now, where we can apply all these things? Okay, so what are the different tasks of the machine learning? As I said, the classification is one important task. Like when you are talking about the COVID-19 pandemic, so the COVID positive or negative, on the basis of some data, you can just if your machine learning model is able to identify that this is COVID positive or this is COVID negative, that is a kind of classification. So the data may be like your X-ray data of your chest, lungs, CT scan data, any pathological data. So the nature of the data may be anything, but your objective is to classify a particular person as COVID positive or negative. That is a kind of classification task. The regression, when we have the continuous data, that is called regression. In fact, suppose we are going to predict, we are going to forecast how many confirmed COVID-19 cases will be there tomorrow or after 10 days or after 15 days, how many recovered cases will be there, how many death cases will be there due to COVID-19, that you want to predict, that you want to forecast. That is a kind of regression problem, because your output is continuous output. The confirmed cases, like 500 confirmed cases, so 500 is a continuous data. Recovered cases, the 200 is recovered cases, death cases, 50 death cases are, so these are all numeric data. So this is what kind of regression. uh, we are now talking about the object detection. So you can identify a particular portion of a particular object. Okay, so that is another task nowadays being performed with the help of machine learning. That is object detection. I will show how object can be detected. Like suppose whether you are wearing mask or not, whether mask is there on your face or not. So it will detect a particular portion of your face, and it will tell you that you have weird mask or not. Okay, like in social distancing is maintained or not. So what you have to do, you have to identify the two person, and the distance in between these two person you have to measure. And if it is less than 2 meters, then what happened? It will alert the masses. It will give the message that social distancing is being violated by these peoples. So that kind of things is possible with the help of object detection task of the machine learning and deep learning. So this is a very graphical scenario of the classification. Suppose you have a sample, two sample, your machine, it will come to the machine learning model that is known as classifier if we are performing the classification task. And on the basis of the historical data, it has evolved the program. On the basis of that program, it will identify whether a particular sample is related to the COVID-19 negative or COVID-19 positive. So this is how the classifier will work. Okay, so this is the classifier. As you can see, this classifier is nothing. That is a machine learning model. We have trained this machine learning model on the basis of the previous data, historical data. And when we have satisfied that yes, model is working well, we have deployed this model in real sense. Just you can have some model is converted into the interface, and then you'll put some data, and it will classify whether a particular person is COVID-19 or not. Okay. There are some limitation of the machine learning. That's why we are nowadays talking about the deep learning technique. So the biggest disadvantage of the machine learning that is cannot solve very complex kind of problem. When you have the image data, when you have the video surveillance data, it's very difficult to develop the model using the traditional machine learning technique. And another important aspect of the machine learning, that is you have the handcrafted feature extractor. Like suppose you have the image data, then you have to extract the features manually on the basis of some feature extraction technique you can apply, and then you can extract the features. This is not the case in case of and one more problem, that if you have the high dimensionality data, uh, there is some limitation of the machine learning. So if you have high dimensionality data, like your 10 dimension, 5 dimension data are available, so it's a little bit difficult to deal with all this kind of data by the machine learning, traditional machine learning technique. So a deep learning can solve this kind of problem. It has the automatic feature extraction facility. It will extract the features. Deep learning model, yeah, deep learning architecture can itself extract the features. So you need not to think about the feature extraction and all. And at the different level, it will extract the feature, low level feature extraction, middle level, high level, and then it will that features is provided to the machine learning model, deep learning model, and then you'll get the output. See, this is the scenario of the machine learning and deep learning. This is the input and the feature extraction you have to perform manually using any algorithm of the feature extraction, and then just you give it to the neural network, artificial neural network. It will identify whether a particular object is car or not. While in case of the deep learning, this feature extraction component is not present, so it is not required, in fact. So that is actually embedded inside the architecture itself. So just you can see the feature extraction and classification, both the works will be done by the deep learning architecture. So you just don't think about the feature extraction. You give the object, and this deep learning architecture will itself classify whether a particular object is car or not. So there is no concept of handcrafted feature in case of deep learning. So I'll not go with all these things. So deep learning application are very, very important nowadays. Everywhere we are now talking about the deep learning model, the deep learning classification techniques. So image classification can be done, object detection, as I said, that mask detection can be done, image caption and labeling annotation. Like suppose image is there, and if you want to know for what the image is, so that automatic caption and labeling is possible with the help of deep learning. Activity detection in the video, that is also medical image, but that is very important domain of the deep learning. That medical image data processing, healthcare data processing, that is also possible with the help of deep learning. That is possible with the help of machine learning also. But I suggest you all to go with the deep learning for all this kind of problem when you have the data of image type, and when the huge amount of data are there, and like suppose uh, high dimensionality data are there, so you have to think about the deep learning. Text classification is also there. Speech recognition, as you are already knowing in your mobile, the speech recognition facility is there, so that can be deal better with the help of deep learning techniques. So I'm just skipping. So this is the basic architecture of the deep learning. The convolutional layer is there, the max pooling, then a combination of convolutional layer and max pooling layers are there. It depends upon the architecture to architecture. The different deep learning architecture are there, different CNN architectures are there. So these number of layers and nature of layers are different in different architecture. Then you have the flattened layer, which converts your matrix data into the column data, and then ultimately given it to the your architecture, that fully connected feed forward network. So this is what simple kind of artificial neural network, where the different layers are there. In the different layers, you have the different activation functions, and that activation function perform some mathematical calculation and then provides output to the higher layer. So this is the convolutional layer. I'm not going to deal with all this. I'm not going to explain all these things because it is a little technical. So pooling layers are there. This is flattened layers are there. Now just see this one. CNN, convolutional neural network, is very popular kind of deep learning architecture. And you have different architecture of CNN. AlexNet, okay. The VGG is another architecture. Google Net, developed by the Google, is another architecture where you have 22 layers. So in terms of number of layers in the deep learning, it is huge. huge number of layers are there. When you are thinking about the traditional machine learning, almost you have 4 layers, 5 layers, 10 layers, 15 layers, not more than that. But when you are uh, dealing with some complex problem, number of layers must be increased. So the different CNN architectures are having different number of layers. So if you think about the RASNet, 152 layers are there. So these are the person scientists who have developed, who has like invented the different architecture of CNN. YOLO 4 is the recent development in the CNN architecture. Now let us come to the application part, like see where we can apply the sentiment analysis, emotional analysis, medical diagnosis, depression analysis, mask detection object, natural language processing, and pandemic prediction, monitoring social distance. So these are all the things which we have already worked, and we have developed the model. In fact, we have developed the interface for all these problem domains related to COVID-19. So I will show all these applicants so that you can think today that how the machine learning and deep learning can be utilized in better way for solving any kind of problem. And in the remaining 4 days, you will try to learn the different algorithms and how these algorithms actually works. So let us feel today that how this ML and DL can be applied in the different problem domain related to the COVID-19. So this is the scenario you might have seen during the lockdown, that the robot is there in the hospital, and they provide the service to the COVID patient. So these are all possible due to the machine learning and artificial intelligence. So this we have experienced all this kind of situation during the pandemic, during the lockdown in 2020. And the drones were also used for the disinfectant spraying, for enforcing the social distancing, for supplying the grocery and supplying the medicines. For the announcement, the drones were used during the lockdown in India. Also, the drones were used in the foreign country. The drones were used for the due to the COVID-19 pandemic. This is the first application which we have worked, that is COVID-19 cases prediction. So what we have done, we have collected the data from the site of Government of India, and the cumulative daily confirmed case, and cumulative daily death cases. This data we have collected. Cumulative data means what? Today, suppose the 100 cases are there, and tomorrow 200. The cumulative data for the tomorrow will be 300. So on the basis of the cumulative daily confirmed case and cumulative daily death cases, we have done this experiment, and we have data pre-processing. Let me tell you, the data pre-processing is very important aspect of the machine learning. You have to make the data presentable. You have to make the data which is most suitable for your machine learning algorithm. So that you have to think, because you are getting the data from the different sources, and it is maybe some noises are there, maybe some unwanted things are there, so that you have to remove. So you just think about the data pre-processing. That is very important part. So data are pre-processed, and the data are partitioned with the training and testing, and the k-fold cross-validation. That is another technique you will learn slowly during all these 4 days, that how the data can be partitioned with the help of k-fold cross-validation. The two techniques, ensemble techniques we have used, the bagging and ghosting, and the model has been developed. Since it has the numeric data as the output, like confirmed cases and the date cases, so MAP is the performance measure, mean absolute percentage error. On the basis of the MAP, we have decided that yes, this is the best model, and then we have performed 30 days ahead forecasting. So on the basis of this machine learning developed model, we are able to say that what will be the situation of the confirmed case COVID cases and confirmed date cases after 30 days. So these are the different model we have developed: begging using community confirmed case, begging using community date cases, and the wavelet technique we have applied here. The wavelet is that is kind of technique which we can use to remove the noise from the data. There are different wavelet techniques are there that you can apply, and it is nothing that is, it's a pre-processing part of the your machine learning development process. So this is the scenario, and the different, we have taken the data of the different country. In fact, we have taken the data of the 7 countries, and this is the the performance of the model on the basis of MAP. Okay, and just you can see that this the model is performing well in case of wavelet with begging and wavelet with boosting, and we have done the validation also. See, let me see you the validation of the model. Okay, so we have selected the best model on the basis of the MAP. If the MAP is less, that model is just, we can say that model is performing very well. Then this is the comparative MAP graph of wavelet boosting model, which is the best model in our case. So what you have to do, you have to apply many algorithms, like 10, 20 algorithms, integrated technique, and assemble technique you have to apply. And among all these developed model, you have to pick the best one. And that best model you have to identify, and on the basis of the best model, and you have to test the model. So this is what the cases of the 7 countries. And we have done the 1 month prediction also. This is the 1 month prediction, the validation and the forecast of the death cases: India, Italy, Russia, and Spain, and UK, and USA. Uh, and the precaution measure also we have implemented. Precaution measure, that is R0. You might be knowing that R0 is very important. That is what the precaution measure. The value of R0 is equal to 2 indicate that an average 2 persons are getting infected from one infected person. So that is R0 is equal to 2. Also, on the basis of this R0, we have predicted the death cases and the confirmed COVID cases during the lockdown in 2020. So this is what one application of the machine learning, that is forecasting of the COVID cases. The forecasting of the COVID cases is one of the application of the machine learning. Okay. And then sentiment analysis we have done during the lockdown. Sentiment means what? As you know, that Twitter is what Twitter is providing the facility to put our emotions, put our sentiment. So on a particular problem, just we can put our opinion on the Twitter, in Facebook. So the Twitter is the most important platform. So that is why we have considered the Twitter data here, and we have extracted the data from the Twitter. The machine learning technique that Python provides you the functions to extract the data from the Twitter platform. So that we have extracted, and we have considered two different, in fact, Twitter handle, that is hashtag COVID-19 and hashtag coronavirus. So on from these two Twitter handle, we have extracted the Twitter data before the lockdown, during the lockdown, and after the lockdown. And for the development of the model, we have considered the data from the Kaggle, that is sentiment 140 data, which is having the 5 lakhs, because it is a Twitter data. So a very important thing is that you have to go for the pre-processing, data pre-processing, because in the Twitter data, what you have the emoji, you have the different kind of noises. So you have to remove unwanted data from the tweet, unwanted data from the tweet. So the data pre-processing is very important aspect when you are talking about the data of the from the Twitter platform. And then you have to extract the features. We have applied the TF-IDF. This is another algorithm that can be used to extract the feature. We have applied the machine learning algorithm, that is logistic regression. And then we have compared the model. We have validated the model, and our model is able to identify whether a particular tweet is positive tweet related to the COVID-19 or negative tweet. So this is what a classification kind of thing that we are going to analyze the sentiment of particular person related to the COVID-19. So this is just you can see, this is the Twitter data which we have extracted from the Twitter handles. And this is the word cloud. In fact, what kind of words are there in the tweet, so that you can see here. And this is the frequency of the data that we have extracted. The total tweets which we have taken are 2 lakhs during the period of lockdown. 2 lakhs data, 2 lakh tweets we have extracted from the Twitter data. So this is the final result of, just you can see, the before lockdown, the negative sentiments are 32.14, the positive sentiments are 67.86. After lockdown, the sentiment has been changed, the ratio has been changed, and the people started thinking about the COVID-19, and the positiveness is reduced to 63.87, and negative sentiment has been increased, that is 36.13. It was 32.14, and after lockdown it is 36.13. And during lockdown 2.0, the sentiment is like positive sentiment is 65.90, negative is 34 during lockdown 3.0. So just you can see that the positiveness is less during soon after the lockdown, first lockdown, and then it is gradually increasing. Gradually it is increasing from lockdown 2.0 to lockdown 4.0. So this kind of analysis you can do with the help of machine learning algorithm. Another analysis we have done, that is global sentiment analysis, also we have done. The previous one is for the India, and this one is for the different countries, those who were suffering highly due to the COVID-19. So this is the process diagram. Again, we have taken the data, similar kind of data from IMDb, ISER, from Kagle. We have used those data for development of the model. Then again, we have taken the Twitter data from the different countries. We have pre-processed the data. We have developed the model. We have tested the model. Once you have decided that, yes, this is the best model, we have given the testing data, and we got the result. This is the data which we have taken for the development of the model. IMDb 50,000 sample, 2 classes are there. Positive samples are 25, negative samples are. These are the data which we have used for the development of the model. See, we have done the deep analysis of the sentiment also, that is known as emotional analysis. So positive and negative are the 2 sentiment. But when you are positive, what are the different emotions are there? What are, if you have the negative sentiment, what are the different emotions are there? That also we have analyzed. So in that case, we have the 7 class levels. In earlier cases, sentiment analysis, we have 2 classes, positive and negative. But when we have done the sentiment analysis, we have the 7 classes: the joy, fear, anger, sadness, disgust, shame, guilt. These are the 7 features we are having. So on the basis of that also, we have done the analysis. These are the word cloud of the data, Twitter data, which we have extracted. And these are the techniques which we have applied. This time we have applied the deep learning technique. So simple RNN, LSTM, CNN, GRU, bidirectional LSTM, CNN plus LSTM. We have combined these 2 techniques, CNN and LSTM, together. And just you can see the performance of the model. In case of CNN plus LSTM, the accuracy is higher. That is 91.11 as compared to the individual techniques. So what we can do, we have to pick this particular model which is performing well in terms of the different measures like accuracy, sensitivity, specificity, precision, AP score. Just you can see that this combination of CNN and LSTM deep learning technique, all the measures, the value of all the measures are higher. So just let us pick this particular model and go ahead for the sentiment analysis and emotional analysis. So just you can see the sentiment analysis of the 7 countries: France, India, Italy, Spain, UK, and USA. The red one is like negative, and this blue one is positive. So just you can see that the India was having the positiveness 72.90, and negative 27.1. So just you can compare the result of positivity and negativity of one country with another country on the basis of this. And this is what we have done, this emotional analysis. Okay, so the yellow bar is what that is positive sentiment. In fact, that yellow bar is for the joy, and all others are negative: anger, disgust, fear, guilty, sadness, same. So in all the countries, just we found that the positive sentiment, positive emotion, in fact, is higher than the negative emotions. Okay, so if you'll see the country India, so the positive emotion is 33.13. Okay, and all others are negative emotion, in fact. Okay, but if we consider the span, the highest negative positive sentiment was there in the Spain people, that is 42.74. So this is what emotional analysis we have bifurcated positive sentiment and negative sentiment with some specific like emotion, and that we have done analysis. Okay, and one more model we have developed, that as I said you, that in healthcare industry also the machine learning and deep learning are being used widely. So at the time, the very few data were available. Just one thing you must know, that data data play very important and crucial role in the development process of the machine learning model. So if you have huge amount of data, the model will become more intelligent. But during the lockdown, first lockdown, this data, the COVID-19 data were not available. In fact, only Chinese, some CT scan Chinese data of the lungs were available. So we have taken those data for the development of the model. These are the data, CT scan data of the lungs. And on the basis of CT scan data, as you know, that COVID, the first wave and second wave of COVID has infected the lungs of the human being mostly, and the oxygen level gets down due to that. And due to that reason only, we have taken the data for the identification of the COVID-19 as positive or negative. So here also the pre-processing is very important. You have to convert the data in a particular format of the pixel. You have to remove some noise from the data. You have to consider a particular portion of your image data. So all these things you have to done in the image processing. Then the model creation, model development, we have used deep learning model. As I said you, for the image kind of classification, the deep learning is best suitable model. So different CNN model we have taken, and very important aspect of this, that we have used explainable artificial intelligence also. We don't want to know whether a particular CT scan data is related to the COVID-19 positive. We also wanted to know that how the model, how your health system is telling that this particular CT scan data is COVID-19 positive. So that how can be explained with the help of explainable artificial intelligence. So I urge you all to see the video of the explainable artificial intelligence. It is available in the YouTube, and it is very important aspect. Whenever if you are doing your research, you just integrate explainable artificial intelligence, especially when you are working with the healthcare system. You are developing a model for the healthcare system. I request you all to use explainable AI, so that each and everything will be explained by the system itself, and then that can be explained to the patient. Like patient may be asked to doctor, how can you say that I am having like cancer? So the doctor explain that, see this image, this brain MRI image, this image, this pathological data, and this all the data says that you are having the cancer. So in the same way, your machine learning model can also explain. Okay, earlier it was the black box. You just give the patient data, it will tell you whether the person is having COVID-19 positive or not. Now you have the technique of explainable artificial intelligence. It can explain you that the model is, if the model is saying that yes, it is COVID-19 positive, then how why it is COVID-19 positive. That explanation will be there. So along with the result, it will explain why that result is being produced by your machine learning model. That is what explainable artificial intelligence. So this model we have developed, and the data sample, as I said you, very small data sample were available at the time. These are the Chinese CT scan COVID data. CT scan image data was there. The COVID-19 infected person 349 images, normal were 397. So we have splitted the data into training and testing. That is the important part of your machine learning. And then we have applied many deep learning techniques: ResNet 50, DenseNet 121, exception, inspection v3, VGG 99, and just you can see that the VGG 99 is performing very well. So we have considered this particular model for the development of health system. We have given the name of the health system as COVIS health system, that is coronavirus identification system. So this is the interface which we have developed. Just you can enter the patient related data, and just you can browse the browse. You can click the browse, and just you can put the JPEG image of your, like your lung CT scan, and then start diagnosis. It will process, and then it will tell you that you have the possibility of COVID-19 positive as 97%. Okay, so the explain can also be done by the system by displaying the image in the different way, because we have used the explainable artificial intelligence over here. So this is what the system we have developed, COVIS Health. Now the depression analysis can also be done. We have done the depression analysis on the basis of the machine learning model. So the depression analysis, that is what the activity graph watch record the different activities of the human being, what actually you are thinking, your pulse rate, this and that, different parameters of the human body can be captured by this watch. And just you consider this data, and just you can classify that a person is having the depression or not. So that also we have done. And there is what one kind of disease is there, that is known as schizophrenia. Okay, schizophrenia. So that schizophrenia disease we have identified with the help of this actigraph data. So we have taken that data, we have considered the 1 hour data, 3 hour data, and 6 hour data. And the two class labels are there: non-schizophrenia and schizophrenia. Schizophrenia is a kind of disease that is somehow related to the depression of a particular person. Okay, so this is the frequency graph of activity of the patient. Two different kind of patients are there. Like one is those who are suffering with some kind of depression related problem, and those who are not. So this the green one is the control data, means the normal person, and this red one is for the patient. So this is what the activity graph that we have extracted from the that watch. And this is the process flow diagram. We have taken the data from the psychose data set, the patient data, and the control data. Patient data means, as I said you, that suffering from the your what you can say, the disease, depression, schizophrenia disease. Control, that those who are not suffering. So divided into the three different categories: 1 hour data set, 3 hour data set, and 6 hour data set. We have done the feature extraction. As I said you, the feature extraction is also very important. Suppose you are having the two features, and if you are to develop a model in better way, so you have to extract the features more with the help of some statistical formula and all the things. And then selection of the model, selection of the features. Suppose you have the 20-30,000 features, you have to identify which feature are the most relevant. That also you can do. That we have done. Feature selection, data partition, then machine learning algorithm we have used. Again, we have used the 10 class fold 10 class fold validation. And the result we have measured with the help of well-known measures: accuracy, specificity, and sensitivity. So these are the data. The case 1 hour data. XGBoost is one of the machine learning algorithm which is performing well for this particular data. And this is the case 3, and this is the data. And what we have done the feature selection also, and on the basis of the feature, uh, we have applied some feature selection technique, and we found that only one feature, the ID of that feature is 4, is most relevant. On the basis of that single feature, one can identify that a person is having schizophrenia disease or not. So this is the model. On the basis of the one feature, on the basis of the feature selection, we have identified the model and we have retained that model. And then once the model has been decided, we have developed the interface. So just you can see this particular see, this is the interface. We have developed the model with the help of Python. This is the interface where you can put your username and password. One of my student has, there are two parts in fact. One is on the basis of your text data, one is on the basis of your voice. It can identify whether the person is having depression or not. Here you can put all your detail. This is login phase, login. These are the two things. On the basis of the text data, this is on the basis of text data, this is on the basis of the voice data. You say something, it will identify whether you are having depression or not. So here you can see, you can choose the file. Bulk data, if you are having related to the ActiGraph, ActiWatch data, that you can put, and you can browse the data from the CSV file, and you just click on the analyze now. It will say the activity graph to you, and here your condition is depressive, means you are in depression. So that kind of classification is being done. So the data can be imported also in the Excel file. You can put the bulk data. Just you can see the first one is normal, the second one is having depression. Here you can import the data in the Excel. This is on the basis of the voice data. See, here you can put your voice, you say something. If you are saying something negative, it will tell you that you are in depression. So that kind of things are also possible. I'll take 5 minutes more, Pawan sir.
Okay, sir. Actually, another resource person have already joined.
Yeah.
Okay, sir.
Please.
Okay.
Now we have developed another model with the help of deep learning that is related to the object identification. As I told you, the mask detection. This is also based on the deep learning. You can run this model in the cloud also. Okay, so this is the model. This is the simple model of the deep learning, which will identify the mask. It will tell you in the voice form whether you have mask on your face or not. So that is kind of object detection. It will detect whether you have the mask on your face or not. Okay, so this is one machine learning, deep learning model which we have developed. Okay, and this is the scenario just you might have seen in the various places. The violation of the social distancing, for that also we have developed the machine learning model. And this is the real model which we have tested on the road of the Bilaspur. So just you can see how this is working. This will tell you the number of violation also. If the two people will come together, it will come within the red rectangle. If it is not, then it will inside the green rectangle. So this is what we can have this kind of model you can develop. This is the another video of the same model which we have developed with the help of deep learning. So this we have deployed in the real sense in the road. Okay, so these are the different applications I have tried to explain you. So what are the requirement in fact? So you have to write the program. Where we have to write the program? You have to write the program in using the Python or R programming language. So what are the interfaces? What are the integrated development environment available for writing the program? The Google Colab, that is cloud-based Python IDE, is available for you, which provide the virtual machine also, and the GPU resources also, because when you are talking about the deep learning, the more resources are required, because the huge amount of data are there, so more resources are required. So in that case, you can take the help of Google Colab. Anaconda is there, Jupyter Notebook is there, NVIDIA is also there, which provides the resources for you for deploying your machine learning model. IBM Watson Studio is there. IBM Watson Machine Learning is also there. And IBM Watson Open Skill, that is especially for the explainable artificial intelligence. So these are the different platforms, tools, and techniques available to you. And just you can go with all these tools. You can explore all the algorithm and tools and techniques, and just you can consider a particular problems which you can use, which you want to deal with the help of machine learning and artificial intelligence, and just you can enjoy. Thank you very much to all of you.
Thank you, Hota sir. It was a very nice and great lecture. Participant, do you have any query? Participant, do you have any query? Any query? Okay, if you have query, you can text to me, message to me. I will forward to Hota sir. Okay. Now I would like to request my colleague Dr. Abhishek Bansal sir to propose vote of thanks. Bansal sir.
Thank you, sir. Sir, it was very nice lecture. So I, on behalf of Department of Computer Science, would like to thanks to deliver the lecture on machine learning and its application. Sir, you have discussed various introductory topics related so machine learning and artificial intelligence. You discuss the difference between traditional programs versus of machine learning program. You discuss various algorithm of machine learning like supervised, unsupervised, reinforcement learning. Further, you discuss various machine learning components and its application like classification and regression. You also discuss various applications like sentiment analysis, emotional analysis, medical diagnosis system, diffraction techniques, mask object detection, natural language processing. Further, sir, you have very well discussed about the project related to a relationship between the machine learning and COVID-19 pandemic. So, sir, your project is very nice, and I think the participant learned a lot from your presentation. Thank you very much, sir. Thank you, sir.
Thank you, sir. Thank you very much for giving your valuable time, sir. And we are going to organize a workshop in the future, sir. And we hope that we will again meet to you on that platform, sir. Thank you, sir. Thank you. Okay, now Dr. Rakesh is there. Dr. Rakesh? Rakesh, sir.
Yes, sir. Good afternoon.
Good afternoon. Okay, how are you, sir?
Fine, sir.
Okay, dear participants, now another resource person has joined. Okay, we have Dr. Rakesh Kumar, Associate Professor and Head in Department of Computer Science and Engineering at Central Institute of Haryana. It my privilege to introduce Dr. Rakesh sir. He has received his BTech in Computer Science and Engineering from Punjab Technical University, Jalandhar, India. And he has received MTech in Information Technology from Guru Gobind Singh Indraprasth University, Delhi. And PhD in Computer Science and Engineering from NIT Kurukshetra in 2015. He started his career from NIT Kurukshetra, where he worked as lecturer and head in the Department of Computer Science and Engineering at Central Institute of Haryana. He has 17 years of teaching experience. He has number of international, national conferences, journal publications to his credit. He is also a reviewer of many international journals and conferences. He has organized many short-term courses and conferences and workshops. He has an active member of many professional bodies. He has guided many PhD and MTech students. His key area of interest include MANET, mobile ad hoc network, software testing, data analytics, and cloud computing. So thank you very much, Dr. Rakesh sir, who have given us this opportunity to introduce and giving his valuable time to our participant. Thank you, sir.
Uh, Good afternoon, participants. At first, I would like to congratulate IJNTU for conducting this international workshop, and special thanks to Dr. Pavan and team who has given me an opportunity to interact with the participants in this workshop. So I will be sharing my PPT. So that. So please let me know whether PPT is visible.
Yeah, it is visible, sir. Please
Okay,
go ahead.
thank you. Thank you, sir. So I think at first I would like to say that it is really very difficult to speak after a good speaker. I have already listened to sir. It was a really nice session. So let's continue with that. Sir has already discussed a few of the things that I have put in my slides. But anyway, it will be really good to learn the new things again and again. So we all know that this machine learning is one of the breakthrough. This has been said by many of the renowned researchers and many of the great person in the world that it will be really a breakthrough, this machine learning technology in the near future. When we were the students, we have been talked about, yeah, we have been taught about the expert systems. But nowadays, expert system has completely gone out of the market. Why? Why this expert system has completely gone out of the market? Because expert systems were able to work only on the basis of the rules that have been inserted into the system. But we want a kind of system that can use its own brain. So this brain can be inserted with the help of this machine learning techniques. That is why nowadays this machine learning is one of the great field that has been talked by almost every fields of the today's era. This has, I think, already been discussed with you. What exactly is machine learning? In the earlier days, when we were doing the automation, we were just giving the input to our system, the program that we write. It means the human or the developer write the program. We give the input data to the system, and according to that, the output is generated from the system. But as I already said to you, when we would like the system to write the program on the behalf of user, then basically this machine learning comes into the picture. Because writing software is really a bottleneck here, because nowadays the speed of hardware has gone up drastically, the cost of hardware has gone down. That is why we would like to go for the much larger and complex softwares can be easily accommodated. So this task of writing the code or writing the program can be done easily by the machine learning techniques. So with the help of this technique, rather than giving the input as data and program to the computer, we are going to give the data and the output. The output is our training data over here. So we just give the system, we just train the system, and computer is going, our system is going to write the program for us. So it is not required us to write the program. And as a result of this learning system, we have to give the input samples. We just train the system in this machine learning techniques, and accordingly the learning method is developed. We will be seeing this in more detail in the few minutes. So this we all know, this machine learning is basically the knowledge data discovery. So here, like we discover the gold from the rock, here we are going to retrieve the data, useful data for the users. Now this machine learning basically nowadays has a key applications in the businesses, where businesses can take few of the complex decisions that can benefit them in the long run. So this is only possible with the help of these machine learning techniques. Few of the applications I think sir has already discussed. We will also be discussing some more applications of this machine learning. Like we can use this machine learning techniques in the area of finance, where we may discover regarding the fraud detections. Like there are many types of frauds going on in the market. Some are sending us the malicious emails, so whether the email is a spam mail or not. So all this discovery can be easily and automatically done with the help of this machine learning. Google has already implemented a tool in the background. That is why some of the mails land up in the spam and some of the mails land up in the your inbox. So this is only possible with the help of your machine learning techniques. So when we have this machine learning kind of scenario, we are able to detect whether a particular mail has been sent by any of the fraudster or not. Similarly, we can automatically detect the credit card score in the finance sector. In the manufacturing sector, we can optimize many of the things. In medicine, this machine learning has a great significance. Like whenever we are going to detect whether a patient is really suffering. I think I'm getting a message that my audio is not going on.
So its audio is good. We are able to listen. Okay. The problem may
Okay,
be on their net. No? Your
okay,
audio is
okay.
good. Sir.
Thank you. So in the medicine also, like we are able to detect whether a particular patient is suffering from a particular disease or not. Because with the help of expert system, mycin was the first expert system that was developed with an intention to discover whether a particular patient is suffering from a disease or not. But in that case, if a patient has some different kind of test or the maybe symptoms, then the previous expert system fails over there. Here the machine learning comes into the picture, which it applies its own brain and write the program on the basis of new scenario also. This was not possible with the existing rule based scenarios. Let's go ahead with this. We all know, like in the case of gardening, we have some seeds, we have some nutrients, we are the gardener and we are the plants. Similarly in machine learning, we have the algorithms, we have the data, and we are the developers, and we have the program that is written by the machine itself. These are some different applications where we can apply this, like in speech recognition, natural language processing, computer vision, medical outcome analysis. We will see some of this in the future slides. These are some great applications like web search. One of the greatest application of this machine learning is used by this e-commerce websites like our Flipkart and Amazon. They are recommending us the product on the basis of our geographic locations, on the basis of our age, on the basis of our past expenditure on a particular website, and the other users, those who are of similar nature to me, maybe of my similar age, who have purchased a particular product and they are recommending a product to me. And with the help of this recommendation, they have been able to achieve approximately 60% increase in their sales. So they are using this in a very great extent. But when we talk about the machine learning technique, there are three things that comes into the picture with reference to every machine learning algorithm component. We have the representation, we have the evaluation, and we have the optimization. Regularly, many machine learning algorithms are coming day by day, but these three components will remain there in each one. That whenever suppose you are a newcomer in this area and you are going to develop your machine learning technique, then you have to focus on these three with reference to area of the algorithm. When we talk about the representation, it is basically the space of allowed models, because here we are going to develop the machine learning model for a particular problem. The problem may be either recommending something, maybe the your sensex prediction, uh, your market prediction, maybe a particular share, whether it will go up or down, or maybe you would like to see what will be the chances that I will qualify a particular test or not on the basis of my studies. So it will consider all such factors, but before that, for every algorithm, we have to we have to create the model and represent the problem in a particular space. But this representation will also take into account the fact that we are expressing models in some formal language that may encode some models more easily than the others, even with the possible set. These are the techniques through which you can develop your machine learning model. You can either apply the decision trees, you can apply some induction based, you can apply some Markov chain model based theorem, naive Bayes theorem, neural network, support vector machine. We will see few of them in the uh, few minutes. But these are the ways through which you can represent your problem. Then after that, we need to evaluate which of this method will be good for a particular problem. It may be possible that in credit card analysis problem, like SVM may be performing a better. It is giving a better result. But maybe in case of cancer detection, neural network is performing well. So we have to evaluate the model that we have developed on the basis of our problem and a particular algorithm, which one is giving us a better result. So evaluation is required. That is essentially how you judge or prefer one model versus the another one. It's what you might have seen as a utility function, loss function, scoring function, or more simple way we said it as the fitness function. We need to develop our fitness function. So how fit a particular model is it with reference to a particular problem? Because it is not like that a particular model will fit in all type of applications and problem domain. We have to change the model depending upon our requirement. So think of this as a height of the landscape of a particular given model, with lower areas being more preferable, desirable than the higher areas in this case. So for evaluation, we have certain parameters, which one is better, like what is the accuracy. Then we may also go with the precision, recall, squared error, likelihood, like the what is the posterior probability. We also keep the probability density into consideration. How much cost is used when we are doing this. Entropy can also be used in certain other parameters. And the final one, now we have selected a particular problem domain. We have chosen a particular model also through which we are going to implement it. We have compared the certain algorithms or the models in this, and then we are going to optimize. Now we are going to optimize our solution with this. So which here optimization is how we search the space of represented model to obtain the better evaluation. Like we have already listened about the local maxima and local minima. So we have to reach to a global maxima and global minima. So this is the way we expect to traverse landscape to find the promised land of ideal models, strategy of getting to where you want to go. Stochastic gradient descent and genetic algorithms are the two one that will be representing for this optimization, because we want our model to be optimized to give us the best result or the best possible combination of results. For this, we can use as the Grady search algorithm may be used, gradient descent may be used, linear programming may be used. Now, coming on to this was about the machine learning. What exactly is machine learning? How we do the automating the automation. Now, what are the various categories? We have already just gone through in one of the slides. What are the various ways through which we can do it? So when we talk about the categories of machine learning, we have the two broad categories only. One is the supervised or we can say inductive learning. And second one is the unsupervised learning. Supervised learning has a particular class of application. Unsupervised learning has a different class of application. Like suppose now I have opened a new supermarket store. Like suppose whenever you go to any of these big supermarket stores, you will find that suppose it is a 3-story building. From the entrance, wherever you will enter, you will first find that at the entrance only you will find the section with the ladies clothing, ladies wearable. Why? Because they know that with the past experience, whenever the person with the family is going to enter into the supermarket store, if first he will buy the food items or the consumable, he will just spend over there only and will go back, because the persons have limited time, maybe 1 hour, maybe 40 minutes, or this is the average time persons are spending in the market, maximum 2 hours. After that, persons start feeling tired and they will go back. So on the basis of this experience, this learning, they have developed that, because this is a kind of manual learning which everybody understands, that in a supermarket store, first section is always the ladies section. They have developed this. Now I'm sharing another example with you. This McDonald, they were not in India. When they were not in India, they have been uh, into the foreign countries, but there they were not making this veg burger. There they were preparing the non-veg burger. But when they were planning to land up in India, they did research. With the help of these learning techniques, they found that in India, most of the people are vegetarian. So if we just launch a single product, it may be possible that we will be in loss. Through learning, they have come to know we have to design a particular product with the help of as per the requirements. So in India, they have found that we need to go with both veg as well as non-veg. Then they entered into another this kind of learning, where they found that we, if we if we launch our product in the cities, there are already various vendors, those who are selling a good kind of product over there. So it will be a really tedious task. That is why they opened their outlets only onto the highway initially, and those highways were meant in such a way that people from who is visiting from one city to another city, because India surveyed that here people take food at 3 times a day, meal 3 times a day. So they planned in such a way that person moving from one city to another city, this McD will come as just a refreshment point of things, so that people can have a light snack over there. And they have also just placed a one big board uh, over there. Through that, they will be able to know this MACD is coming, and children will start shouting. Suppose you are going with your family, and as soon as I have 2 kids, as soon as they see the big board of them, they start shouting, "Papa, just have a break over there." As a result of that, so this is the strategy through which they are approaching. They are going ahead. So when we talk about this 2 broad techniques, supervised and unsupervised, in case of supervised, we have some training data, we have some past knowledge, and we know the categories. As I said to you, here we have the categories, maybe men's section, maybe women's section, maybe kids section. Here the categories are known to us. We just need to put the items over there. But let's talk about the case where we have, suppose, more than 3 floors, or maybe we have more than we have a single floor in my supermarket store, and I have to now categorize the product. So I don't have the options in which I have to categorize. I don't know whether to categorize in the men's section, women's section, or all the items must be placed in a single place. Like if a person is thinking that, if suppose I'm going to buy a pen, it may be possible that I may be willing to buy a bread as well as a butter. But in real life, in Indian scenario, with the help of this learning techniques, they have come to know this is not going to be feasible. So we have another category of the semi-supervised learning where training data includes the few desired outputs. We have the few set of categories, but it may be possible that we may categorize it into the more categories. And the fourth one, that is the reinforcement learning. It says there is a rewards from the sequence of actions. Let's see each one. So unsupervised, semi-supervised learning is in between the supervised and unsupervised. But in case of supervised machine learning techniques, the model, it learns by using the labeled data. We have the X, we have the corresponding output Y that should be there in the input itself. In case of unsupervised machine learning, trained using the unlabeled data without any proper guidance, we may have the two categories, we may have the 3, 4, 5, 10 number of categories may be there. In case of supervised, we have the labeled data. In the other way, we have the unlabeled data. In case of machine learning, we have different techniques like regression, classification. Like sometimes we are going to predict the future on the basis of past history, or maybe we are going to classify the things into two categories. These are the basically two major applications of supervised learning. Either like we are going to predict the stock market. This is some kind of prediction on the basis of past history, or we are going to classify it maybe in binary classification, whether a person is suffering from a particular disease, yes or no. We may also have the multiple class problem, whether like suppose I am going to offer a credit card. I would like to know the user, which particular category of credit card will be more useful for him. Maybe if his salary is between up to 20,000, this class of credit card will be good. Maybe if he is earning from 20 to 50,000, then this one is better. If he's earning between 50,000 to 1 lakh, then this particular credit card will be better. And if he's earning more than 1 lakh, then this is the gold class of credit card that may be offered to him. And accordingly, these companies are going to perform. In case of unsupervised learning, the problem domain is a little bit different. Here we do not know in how many classes we have to categorize the thing. So we are going to group the similar product together and dissimilar product together. As I have already given you one of the example, whether to keep the bread and butter together, it will lead to as a good business decision or not. Many of the businesses have started applying these machine learning techniques, and they are getting great results according to that. Algorithms that may be used in these supervised learning, we have the regression. In regression also, if it is a linear class problem, we may apply the linear regression. If it is a complex problem, we may apply the logistic or the other higher end class of regression techniques. We have the support vector machines, we have the neural networks. In case of algorithms, the first and the foremost algorithm that we have been using in unsupervised kind of learning is the a priori algorithm that is used for association. But we may also go with the k-means clustering techniques. Then in case of supervised learning, we would like to calculate the outcomes, as I said, the prediction or maybe the classification. But in case of unsupervised learning, our aim is not to predict something, or we are not going to categorize the things. Here our aim is to analyze the pattern, in what pattern people are going to buy the product. Like suppose you would like to know, like you have been, I think, seen many a times, like you have been given of an offer by the supermarket store. It's sir, between, if you go if you come to our supermarket store between 20 to 30 of this month, you will be given 10% off in the men's wear section. So they have discovered the pattern that during this particular hour or during this particular duration of the month, people are less visiting this section and we are getting less income. So they would like to offer the things. Another example I would like to share with you. Many of these big brand stores, like in the northern part of country, when you come here in winters, here the temperature is quite low. But when you when the summers will come, here the wearing pattern will be totally different, because there is a huge variation in the temperature. So these stores, those who are manufacturing the clothes, big brands clothes, either suppose they have manufactured lot of clothes in this for this winters, but at the end of winter they have two options. Either they have to keep those up to the next year, but the storage itself takes lot of, it involves a lot of cost. As a result of that, they don't want to store these products up to the next year. Second option they have is to just sell those products at the discounted price. Sell those products at the discounted price. But in that case also, again, there is a problem. How much discount they should offer? Either they have to offer the discount at the initial level, 50% discount, maybe 80% discount, maybe 10% discount. So they have to analyze the pattern on the basis of past history. Like suppose in the month of January, maybe around 26th, maybe 30th of January, suddenly the weather will change and people will move to the different class of clothes. And we have to offer the discount accordingly. And they analyze such kind of pattern with the help of these machine learning techniques, and they recommend the supermarket manager on the basis of that. And in case of reinforcement learning, one of the best example is the today's we have the Google self-driving car. Even in India, Mahindra have launched this ADAS feature in the XUV 700. That is the a kind of self. It is not completely a self-driving car, but it can learn few of the things on the basis of the white mark on the road. Accordingly, it can adjust itself. It can also sense whether any object is in front of car or not, and accordingly it can apply the brakes. It is not full-fledged self-driving car, but still many of the feature of reinforcement learning, because action is taken on the basis of the previous event. So when we talk about this machine learning in supervised class of learning, we give the input to the machine, we give the training data. This data may be in the form of text, it may be the document, it may be the images, it may be sound, it may be video, whatever you would like to analyze the pattern. And we have to give some labels in which you would like to categorize the things, and you will apply the machine learning algorithm. The machine will train itself on the basis of the training data, and then you will give the machine to some kind of testing data on which you would like to apply your problem. You would like to apply your model onto the real life problem, and there you will predict some of the things. So it is a kind of predictive model. In unsupervised learning, here we are only giving the data to our machine learning algorithm. Here we are not going to give the label as in the previous case. The model is going to find the labels on its own. It may be possible that it may find one label, maybe two labels, maybe more than two labels. There is no particular category in this. So in supervised learning, here we have given the labels in the form of like dots, maybe plus symbol here. In the first figure, you can see we have the stars. In the second one, we have the unsupervised. Here, all are the dots only. Now we have to categorize it on the basis of our own knowledge, maybe on the basis of our own experience. And in semi-supervised, some of them are same and some of them are different. So when we talk about this supervised learning, basically we have a function in which I am giving X as an input and I am going to get Y as the output. But Y and X are prior known to us. Here in this case, we may either go with discrete kind of function or maybe the continuous kind of function. Discrete and continuous, I think it is well known when we would like to categorize the thing in 2 or 3 categories, as we have discussed, whether a particular user falls under the category of fraud or not, it is a kind of classification or discrete. But when we would like to predict the stock market, it is a kind of prediction, and it is will be go into the continuous kind of things. These are the categories of supervised and unsupervised learning. One of the most important technique in case of supervised learning is the decision tree induction. This we also use in our day-to-day life. The decision tree will also do in our day-to-day life. Like in today northern part of country, you can see whether my child will go to play outside or not. The decision will be taken on the basis of few parameters, like whether today it is a daytime or night time. If it is a daytime, then again I will see whether it is raining outside or not. If it is not raining, then again I will see what is the temperature outside. If it is quite low, if it is a cold waves are going on, then again I will see yes or no. If cold wave is not going, then I will see whether some of his friends are playing or not. If some of his friends are playing, then I will allow him. So in real life also, we are taking the decisions in a tree-based manner on the certain parameters. If one of the parameters is not satisfied, I am not going ahead. Like if it is raining outside, no sense my child is going to play outside here because it's a quite cold in northern part. Similarly, in our day-to-day life, like suppose you are going to analyze whether a particular person is under the risk category with reference to the credit cards. So this person is a risky or not with reference to a particular as a company who is offering the credit card. Is it really advisable to offer the credit card to a person whose credit history is poor? So such kind of decisions are taken on the basis of decision tree kind of inductions. We may apply some Naive Bayesian algorithm also, which uses the Bayes theorem. Similarly, we have the neural networks in which we have the multiple layers. In one of the layers, we have the input layer, another one is the output layer. In between, we have some intermediate layers. Intermediate layers may be more than one in case of neural network, and accordingly, number of neurons may vary. With the increase in the number of neurons, your machine will be able to solve the complex problems also. Similarly, in case of unsupervised learning, the most important one is the clustering one or the dimensional reduction technique, where I would like to just do the association kind of things. So here you can see when we are doing the training and testing, here we are not giving any kind of special labels. Rather, both training data and test data, it is all coming from the same set, that is the universal set. But we may, in real life, we may have the this testing data totally different from the universal set. So when we are talking about whether it is the supervised category or it is the unsupervised category, our main aim is to just reduce the error. Error should be reduced, accuracy should be high. So in case of supervised, low E out or maximum probabilistic terms are used, like where we have one of the equation, it says we have the training set, we have the E out as a testing set. We will go into the detail in future slides here. So our aim is to just reduce the error and categorize the things into the right category as per the labels. For this, if our training data and test data is coming from the same set, sometimes if we give too less training data to train the model, our model is not properly trained, and accordingly the accuracy will go down. And similarly, if you train your model with too much of data and the same set of data is going to be used again from the universal set, it may be possible that your machine is going to give you the good accuracy, but in real life it is going to fail. So we have to train in such a way that it will not fall into any of the case of underfitting or overfitting. It happens only when we do the training not in a proper way, with either too much of data or too less data in case of training. So there are several factors that affect the performance of your model, like which type of training is provided, the form and extent of initial background knowledge, the type of feedback provided, learning method is used, And then 2.1 factors are the modeling and optimization that we do. Let's see ahead. So the success of this whole machine learning, in which application or in which problem domain you are going to apply, it depends on some of the other factors also. Let's see, like these are the classifications which we have already seen. Either we can classify it into the supervised or unsupervised. In case of supervised, we have the classification or categorization or the prediction in case of regression. And in case of unsupervised, we have the clustering and the dimensional reduction. Let's go into the detail in case of unsupervised, where we have the clustering kind of thing, where we have the clustering. Clustering is a way through which you can categorize the unlabeled data in one or the n number of groups. We may either use the k-means clustering. This is one of the important method of clustering. It says iteratively reassign the points to the nearest cluster center, in which we have to give the algorithm the number of clusters in which you are going to divide your points. Maybe if you would like to have 3 clusters, you have to give the value of 3 here. And accordingly, the algorithm will iteratively reassign the point to the nearest cluster center. And again, it will form the new clusters and check whether it is in the how much is the center from the other points. And accordingly, it will form the cluster. Another way is the agglomerative clustering. In that case, the algorithm starts with each point as its own cluster and iteratively merge the closest cluster. Suppose we have 100 points, so all the 100 points will assume itself as a separate cluster, and after that it will start comparing its property with the nearby nodes, whether it matches or not. If it feels that the nearby node is also having a similar kind of properties, it will start grouping it with this. So our aim is to check the coupling and cohesion. What are the possibilities in that case? We would like to have the low coupling and high cohesion in that case. Like whenever you are forming any kind of cluster between the two nodes, they should have maximum common properties. And when there are two separate clusters, they should have maximum uncommon properties. And another approach of clustering is the mean shift clustering. In this case, we will use the probability density function. On the basis of that, the clusters are formed. Then another category of clustering is the spectral clustering, in which case we split the nodes in a graph based on the assigned links with similarity weights. We assign the weights to each of the nodes in the graph, and on the basis of that, this clustering is done. You may use any of this clustering method, whether it is the k-means or it is the agglomerative clustering, which is a different one, top down, otherwise the bottom up. Ultimate aim is to group the nodes of similar nature together. It may be possible that in some cases I would like to identify whether there is any outlier in it. Like suppose we have a data of suppose 100 users. I would like to identify a person who is a fraud out of that. So here the purpose is not just grouping the user. Here the purpose is to find the outlier. Who is the user whose pattern is different than the other users, those who are in a particular group. So this is only possible with the help of identifying the user who is an outlier in the group. This is possible with the help of clustering. When we talk about classification, we have to give the labels here. Like here in this case, we are giving this image. This is an apple. The lower image, it is a tomato. The third image, it is the cow. So accordingly, we have given the input. We have the function, which is of the form x, and we are going to predict the y, and we are giving the training data. This is a given training set with labeled examples x1, y1 up to xn, in. We have the x, we have the y. Now it is to estimate the prediction function f by minimizing the prediction error. In case of testing, apply f to never before seen test example. Here testing data is completely the new set. Like here, we have given this is the training data image we have given, and now we have the test data. So if the test data, the product which we are testing, it is from the same set, then definitely the machine is going to perform with good accuracy. But if you are going to check a completely different product, then accuracy may little bit go. Then we may use the different features, like we may take the pixels, we may use the histograms, we may use the descriptors. Now let's move to the other category that says the nearest neighbor, KNN technique that we use in case of supervised kind of learning. We would like to classify the things. So this is the test example. We have the training example 1 from class A. We have the training examples from class B or class 2 with the red dot, and we have the blue dot. Now we have the test example that is a little bit different. So it will label the triangle example nearest to the X. It will just compute it either on the basis of the Euclidean distance, or maybe some other distance is used for computing this test example, whether it is nearer to the class A or it is nearer to the class B. So all we need to is a distance function for our inputs. So no training is required in this case. So we have a linear kind of function to separate the class. It's the linear classifier. It is a very simple one. We have just computed a particular example to a particular class on the basis of distance. But in some scenario, the problem is not so simple. So we have to design some complex kind of classifier to classify a particular test example to a different category. In that, we may either go with the support vector machine that uses a different kind of algorithm. We may go with the neural network, as we have said. We may go with the different layers. You can apply the neural networks with more number of nodes for the complex problem. We may also go with the Naive Bayes theorem, which uses the Bayes theorem. We can also go with the Bayesian belief network, logistic regression, linear regressions may be used, random forest algorithm may be used, and k nearest neighbor we have already seen that we can use. So which is the best one? This we have to decide on the basis of the evaluation parameters. Now, this is the recognition task and supervision, as we can apply the supervised learning in case of our natural language processing, maybe image processing, in any other kind of fields. So images in the training set must be annotated with the correct answer that the model is expected to produce. Now, in this image, it is a motorbike. We have captured it and provided it as an input to the machine. Now, this is the spectrum of supervision. Now we have the too many images here, and we have categorized these images into a particular group, whether it is a human image, whether it is the automobile image, whether it is some kind of animal image. So if you have categorized the things properly, it is a fully supervised learning. In the third side, you can see we have categorized the humans together. In the second one, it is weakly supervised, because one of the car is in this direction and another car in the opposite direction. The animal is also pictures taken in a different background as well. So it is a weakly. In the first one, that is a completely unsupervised. We have the person along with the animal. We have the person along with the automobile, and we have more car together. Now it will be difficult for the system to judge it. So it is a generalization kind of thing, where how well does a learned model generalize from the data that it was trained onto a new test setup. So I would like to train my model with the given data in such a way that in future, if the data is little bit changed or the pattern is little bit changed, still my model is able to perform. So this is only possible when we have a large training data with the wide variety of the labels. Those are the possibilities. If we have trained the machine with very less data, it may be possible that the machine is not going to give us the appropriate result at the initial level. So we have to train the machine, train the model iteratively again and again. This is what Amazon and Flipkart and the other websites, they are doing it regularly. They are regularly getting the data of the users. I think many of us has seen that Google is storing a lot of our data. Google is storing a lot of our data. Which data I'm talking about? You can just go to the Google is storing maps information also. Which place I have visited since morning to the evening, or 24/7, they are storing the data. They are also storing what activities I have performed in my activity. I think many of you have seen my activity. Whichever websites I have gone through, or whatever things I have accessed, being logged on to the Google, everything is Google is storing in my activity. And also in maps, it is storing which places I have visited. Now, the thing is, how it can be beneficial for any organization. Let's share another example with you. Like suppose I'm chatting with my one of my friend on, suppose maybe Twitter, maybe suppose WhatsApp, or maybe suppose Facebook. I'm chatting with one of my friend, and suppose my friend writes to me that your picture is not coming clear. I just responded him back, yesterday my son broke my laptop and my camera is not functioning after that. So the other person replied from my friend replied that, okay, you can get it repaired from the market. I replied that no, actually it's been 3-4 years I am using the same laptop. I am trying to buy a new laptop. Now this kind of information will be a big breakthrough for these organizations, those who are selling the laptop. Now they will start sending me start sending me the offers on the laptops, because it shows that I'm the person who is in need of laptop and planning to buy a new one. Similarly, Google is also storing all our data. Like since morning, I am supposed which places I have visited for the past 1 month, maybe 1 year. It is storing all that. Now, what Google is doing with that? Maybe one thing, they are going us to offer the advertisements. Another thing, you will find, suppose some companies are giving you offer. Like suppose there is an offer to you for 4 nights and 4 days 3 nights to stay in, suppose Manali. They are giving us the offers. They track our past history, whether this person is visiting the places of such kind or not, whether this person, suppose they have come to know, suppose in the morning I am in Chandigarh, and suppose by evening I am in, suppose, Mumbai. So it shows that I have traveled through the plane. It shows that I am a frequent traveler uh, by air. So this kind of information is quite crucial for the businesses who are offering the flight services. Similarly, if I am traveling by road in my own car, accordingly such services or such offers may be given to me. You will be amazed that you will never find any offer which is not in your range. Like suppose if I can afford a travel package of up to, suppose, 1 lakh, so I will be definitely being offered into that bracket only. ऐसा नहीं होता, it never happens that कि I'm a person who can afford suppose 1 lakh rupees on traveling, they are offering me 10 lakh kind of packages. So they have the proper selection of users, and accordingly they are offering the things. This is only possible with the help of machine learning, because by human it is not possible to store that much amount of data manually, as well as to analyze that data manually to generate the pattern. If it is being done automatically, then only it is possible, otherwise it is not possible. So we are talking about the this we have discussed, when you are generalizing your model to predict the things, you have to check which kind of bias and variance you are giving it to your systems. So models with too few parameters are inaccurate because of the large bias, not enough flexible. But suppose if you have a model with too many parameters, like suppose I am going to detect whether a person is a fraud or not in case of credit card fraud detection. Suppose I am having the parameters like whether he is an employee or not, how much salary he is getting. Suppose I am having another parameter key, how much return he is filing, whether he's filing the return or not, whether he's having a single PAN card or not, whether he's having a single Aadhaar card or not. Now I'm having too much of questions, and some of the questions are repetitive kind of thing. Like if a person is having PAN card, then it means that he's also filing the return. So sorry, if a person is filing a return, it means if he is having a PAN card. So such questions are repetitive. So it is advisable to remove few of the questions out of it. Now, my next concern is when you are finalizing the patterns, in this case, it is understandable, like you are going to detect the frauds from the credit card. So you are basically focusing on the person's income or maybe the person literacy rate or the person geographical area. It is simple. You will be able to finalize the appropriate uh, parameters in this case. But let's think of the case when we have the data with reference to a particular disease detection. I'm going to detect whether a person is suffering from a particular disease or not. In that case, all the parameters, suppose this is the blood sugar level, this is suppose hemoglobin level, this is another test. So these tests, these parameters will be varying. Suppose some of the test values will be varying between 0 to 1. In some of the tests, the values will be varying between 1 to 100. In some of the tests, the values will be varying from -30 to +60, and so on. So now I have to decide the particular parameters such that the parameters are not repetitive, as well as the values in this range will also be comparative to each one. So we have to normalize the parameters also. Otherwise, what will happen? They will be giving the parameter will the large value will outdate all others. So we have to do such thing with the help of bias and variance. So bias variance trade-off, it says high bias and low variance, and we have the low bias and low variance. Accordingly, they will be kind of underfitting and overfitting. So we want in our system, the system should be trained in such a way that in case of accuracy, the system will perform the best. We want the test error should be as less possible. So with the passage of time, when we have the low bias and high variance, this will occur. So effect of training size, definitely it is going to affect. The larger the training size, the results will be better in the due course of time. So no classifier, as we have already discussed, no classifier is inherently better than any other. We need to make the assumptions to generalize the things. Three kinds of errors are there, like the inherent, those are the unavoidable kind of errors. We cannot, suppose we have some missing data. So this is a kind of unavoidable error. We cannot do something for that. Then we have the variance due to inability to perfectly estimate parameters from the limited data. This is also kind of problem. So we have to choose a simple classifier if we would like to reduce the variance. We would like to regularize the parameters. We would like to get more and more training data. More training data, system is going to perform in a better way. These are some of the classifiers like K nearest neighbor, SVM, support vector machine, boosted decision tree. Let's see a few of them here. So when we talk about the classifier, it can be further divided into two categories, whether it is the generative model or it is the discriminative model. In case of generative model, it represents both the data and the labels. In case of discriminative models, it learned to directly predict the labels from the data. In case of generative, it often makes use of conditional independence and priors. We have the examples of naive bias and Bayesian belief network in case of generative. In case of discriminative, it discriminate the two things with some linear boundaries. Maybe the logistic regression, SVM, or decision trees, we are of this category. So here, in this classification, we assign the input vector to one of the two or more classes, whether it is the R1 class, it is the R2 class, or R3 class. Accordingly, we have given the boundaries. Here we have the clear-cut boundaries. So any point that will fall on R1 area, it will basically near to the R1, and it will be classified into the R1 category. So we can apply the nearest neighbor classifier with this Euclidean distance only, and the points will be classified on that. You can also go with this with the help of Voronoi partitioning in 3D data also. So we can do this in case of K nearest neighbor. We may also go with this K nearest. Here the K will be 3, maybe 5, depends upon the number of neighbors I am going to consider. The larger the value, better the result, but the machine will be taking too much of time. So these linear SVM, that is the support vector machine, this is something which works on a similar kind of function, the linear function, which separates on the basis of two hyperplanes. Hyperplanes are there, on the basis of that the points are partitioned. Then the points, those who are falling in between two planes, those will be decided on the basis of another parameters comparing with the other one. Those will be taken from the data set that are linearly separable, will work out great. But what if the data set is just too hard? So we can map it to the higher dimension space. We may go into the higher dimension for non-linear kind of classes. So it is going to take more time to converge the algorithm. So these will be the non-linear SVMs where we apply some complex functions where the boundaries are not clear in just one dimension, as you can see with this simple algorithm. So we apply this SVMs in the image classification where we pick an image representation like we have seen in the previous case. Then we pick a kernel function, then compute the metrics of kernel values between every pair of training examples with the help of pixel values, and accordingly the vector is computed. Then we generate the hyperplanes and we categorize the things. In case of SVM, we may go into the binary class problem or maybe into the multiple class problems, and it will work fine. So this SVM also have some advantages as well as disadvantages, but it all depends upon a particular application or the problem domain, how much accuracy, how much precision we are expecting, and accordingly it will be performing. The third category of this is the neural network that we have already discussed. Like in case of neural network, it may have the few of the layers, maybe the input layers, output layers, and accordingly intermediate layers are kept over there. So we increase the number of intermediate layers and the complex problems may be solved. So in the end, I would like to say that it is a simple overview of some techniques and algorithms in machine learning. Furthermore, there are many more techniques that may be applied. Like we have not gone into the much detail of SVM and the neural network. It can be done in the future lectures. But till now, if you have any queries, these are some of the resources, data sets, or the repository data sets that are available. If you would like to just download the data and you would like to just apply onto this straight away. I think in the previous lecture, sir has already discussed we can use these in the either in the R Studio or maybe in the Python, or maybe if you just would like to simple run use this, you can also use the Veka tool. If you are just the beginner, you can just use the Veka tool, and simple algorithms are there to just input the data over there and apply the algorithm. It will give us your result. These are some reputed journals. These are some reputed conferences in this area, and these are the references that we have used for this presentation. I will be sharing the PPT with the sir, and sir will be sharing it with you. So if you have any query, we can take few of the queries as we have some time with us.
Dear participant, if you have any query, then ask. Participants, if you have any kind of query, then ask to sir. Okay, or otherwise you may send a text message or email to me. I will forward to sir also. If you have any kind of queries. Okay, sir, can you share some kind of references to the students that can be beneficial for the
Yeah,
beginners?
so this is in the PPT itself. I will be sharing PPT with you, sir.
Okay, okay, sir. Okay.
The last slide is references only. We have the data is also given. We have some reputed journals are also given in this area, conferences, and the references for this PPT. I will be sharing PPT with you. You can share with the participants.
Okay, I have muted all, so I have unmuted some participants so that they can ask if they have any query. Okay, they have been unmuted. If you have any query, you can send to the question. Vijay, you want to ask something? Vijay? Vijay Bhaskar ji.
No, Vijay Bhaskar is our next resource person. So he
Okay,
joined us.
okay. I think there is no query at all. So let me propose a lot of thanks to today's resource person, Dr. Rakesh Kumar from Central Institute of Haryana. He has given a wonderful lecture on machine learning and its category. He has explained what is supervised, unsupervised learning, and how to categorize the data, what is data mining, what is KDD. He have given different applications of machine learning, for example, where it can be used in web search, in finance, e-commerce, in robotics, in debugging and social networks. He explained different kind of learning, supervised and supervised, semi-supervised and reinforcement. Sir, it was very good and very elaborative lecture, and I hope that our participant got the benefit from your in-depth knowledge. I again thank you, sir, for giving your valuable time to us. Thank you, sir. Thank you so much. Okay, sir, I have sent you a link also, Rakesh sir, for your honorarium. I have sent you a mail also. Please fill it and send to me.
I will send you both, sir.
Okay, I think our next resource person has joined, Dr. Vijay Bhaskar Singhal. Okay, sir, welcome to this session, sir. Now I request Dr. Sudesh Kumar to introduce today's resource person, today's session resource person. Dr. Sudesh, sir.
Okay, so hello everyone. Myself Sudesh Kumar, Senior Assistant Professor in the Department of Computer Science, IGNTU. Now I would like to welcome to Dr. Vijay Bhaskar Semwal sir. He is Senior Assistant Professor in the Department of Computer Science and Engineering at NIT Rourkela, Odisha. And his research area in artificial intelligence, machine learning, robotics, and soft computing. And he's also received some reputed award like IEEE Outstanding Volunteer Award in 2017 at IIT Roorkee. He's also received the grant to present a paper in IEEE Telecom 2016 at Singapore. He's also doing some good research project in the area of machine learning, and it may be related to the AI. And he's also published more than 20 international research paper in reputed journals like SCI Index journals, and also attend some conferences and present the paper like IEEE, Springer, many more. So again, I welcome to you, sir. And now I hand over this session to Dr. Vijay, sir.
Excuse me, I just want to add some lines regarding Dr. Vijay Bhaskar. Actually, at present, Dr. Vijay Bhaskar giving his services to NIT Bhopal. He already given many his services to many reputed institutes like NIT, Raul Kela, and Triple IT like this. So I just
NIT Kurukshetra.
Kurukshetra also. So recently he is working in NIT Bhopal. Now over to
Okay.
you, Dr. Bhaskar, for lecture. Thank you.
So thank you, Neeraj sir. Thank you for correction, as well as Sudesh sir for nice introduction. So there was minor correction already corrected. I was currently working at NIT Bhopal, okay, as an assistant professor. Earlier I was in NIT Raurkela. So without further detail, I will start my presentation. First, I will share my screen. So I hope my screen is visible to everyone now. Yeah.
Yeah, it is visible, sir.
Okay, sir. Thank you, sir. So thank you. So today the topic already, I think that the introduction already 3 session was completed. So introduction of machine learning was almost done, and now we are aware of machine learning. And the topic which I am going to cover right now is feature engineering, dimensional reduction for model selection and fitting. Because in machine learning we are expecting we'll fit some model, whether mathematical model or computational model, which will tune over the data set whichever is available with us.
Dear sir, your voice is repeating. If you are using 2 or more devices, please mute one device, sir.
Okay, sir. Okay, sir. 1 minute. I have removed, I think that meeting. Still it is repeating, sir.
Now it's okay, sir.
It is okay now, sir. Okay, fine.
Oh, yes.
Okay, perfect. So I was discussing about feature engineering and dimensional reduction for models. So in machine learning, we used to expect to design some mathematical model which will fit over certain data. Okay, as data-driven techniques. So it depends on the nature of data, whether it's textual data or some graphical data, image data, or video, audio, or sort of. The topic which I am going to introduce is features. The feature is actually elements by which we used to represent the data. Okay, so it is like suppose I am a human being or I am visiting to doctor, and doctor has to classify whether I am healthy or unhealthy. So in this case, they will measure our temperature and the BP. These are the feature we will consider, and maybe it is 2-dimension data. So we used to represent by X is the data set which is 2-dimension of data. Temperature and BP are my 2-dimension. You can represent by this temperature and BP. You can have multiple level of classification, binary classification, ternary, and somewhat. So data we used to represent the output level. If it is supervised learning, so each sample. Suppose this is sample 1. This is suppose Ramesh. Temperature is recorded 98 degree Fahrenheit, and the BP is somewhat on 90. So we'll tell them whether healthy and unhealthy. Similarly, other patient is coming. In this way, if you see the dimensity of this data, it is 2-dimension data, and number of sample which we are concerned, it is maybe 100 per patient visited today. So I can consider 100 patients are here. So this way you can represent the data. So I'm talking about feature. Feature is these dimension by which we used to represent or visualize the data. Now the question is coming, before coming on the feature engineering, what is feature selection, which are feature extraction? Dimension reduction is becoming very important. Generally, real time you find the 1,000 dimension data or 2,000 or 10,000 or billions or millions also many times we are supposed to encounter. So this time the accurate number of dimensity is becoming many times problem for us. The model will not perform better if you consider more and more dimension data. Those with some visualization, I will show later on how dimensionality helping us to understand the non-linear data as linear data in the high dimension speed. But increasing the dimensionality will always come in the computational cost, and which will drastically decrease our performance. So increasing the number of feature or dimension will not always improve the classification accuracy or somewhat predictions. Okay, whatever we are doing. So our performance is going to down. You can see the curve also. As we are increasing the dimension, the performance is after certain point, it is going to drastically down. So how we'll get to know that at what time our performance is highest and after that it is going to down, so we'll stop. In practice, the inclusion of more feature may actually lead to worse performance. Those better visualization, better representation is possible, but many features are redundant, which is not adding any important information. We require such a number of independent features which is carrying the sufficient information, not redundant information. So as I told, the dimensity always data I will represent in terms of x, which is two-dimensional data. That means two feature, maybe x has 100 samples, S2, S3, S 100 samples. So I'm not going what is supervised, what is unsupervised, that you'll understand. So the number of training example require increasing exponentially with the dimension d. If you will increase dimension from d to d plus 1, the growth will exponential. Okay, as I'm moving from two-dimension data to 3D, the growth is like k raised to power d. Okay, this much of growth. How it is happening? That I'm going to present here. Now, suppose we have k equal to 3. There is 3 bins, 3 different categories of classes. Yes, 3 different category. One is red dot, another you have blue, green square, and third one is this triangle. There is 3 different category of it. Okay, so you are representing in one dimension, only one dimension. You are representing in one dimension. So you require 3 bin to represent the 3 different categories so that you can easily classify like minus, less than minus 3, you are considering this is red dot. Less than 5, you are considering at minus 3 to between 5, you are considering at these blue squares and then, sorry, green square and then blue. This way you can categorize 3 different units required. So data is not that much separable data. You can see that there is overlapping. There is no clear cut demarcation or boundary so the data can be. So to classify data, what we can do? We can increase the dimension. As I'm moving from d equal to 1 to d equal to 2 dimension data. So the k is number of classes. It will become 3 square 9 number of different combination. Okay, for each samples. Earlier I'm representing with single dot x1, xxx values. Now what I'm going to do, I'm considering x1 and x2, the pair of x1 and x2. Okay, so that is making you can see that convention. Like you can consider that I'm representing with the 3-bit 0 0 0 0 0 0 1 1 0 1 1. By 2-bit I can represent 4. By 3-bit I can go in 8. 2 raised to power 3, 2 raised to power 2, 2 raised to power 1. This is we call exponential growth as we are increasing just by certain factor. Okay, so that's why the growth will become exponential, like d raised to power 0, d raised to power 1, d raised to power 2, d raised to power k. This is exponential growth, which will become computationally intraceable after some time as growth. That's why you have heard about in computer. This is NP-hard problem. As we are going, if you go for 3 dimension, x1, x2, x3, same data you can represent, no problem. If dimension is 1, 2, 3, that is okay. We have no problem. We can increase until unless we are having resource constraint. But it doesn't mean that we can play with the data. If 2 dimension is sufficient, no need to go in 3, because in 3 dimension maybe you have better visualization. In 2D you can see that the data which was non-linearly separable and some misclassification was happening. But in 3 dimension data is separate. 3 different boundaries there where you can find red is separate from blue is separate in 2 dimension and 3 dimensions also. In 3 dimension it is become 3 raised to power 3. That is 27 kind of bins of points are required for these things. So you can see the growth 3 square, 3 cube. That is exponential growth. As number of training example require increases exponential. So what should be our objective? Where will we stop? The question is coming. So now the question is coming. We have to select such an optimal set of features of lower dimensity to improve the class. Our objective we have to improve our classification accuracy. But up to which extent? We have to go up to certain point where we are not losing performance. So we have to choose such an optimal set of features of lower dimension to improve classification accuracy. This is the objective. It is not that we have selected a huge number of features, but the accuracy is almost very less that we don't want. So different method will be used to reduce the dimensity, because the reduction of dimensity is important, so that we can remove unnecessary features, unnecessary dimension. One is feature extraction and another is feature selection. So I'm fully confident that up to now you have heard this term, what is feature extraction and what is feature selection. Those some of the participants can be new, but up to now they have very much introduction of both the term feature extraction and feature selection. I'm not going depth. I'm just telling what is feature extraction. And so these are dimensionality reduction techniques. From the given set of features, I'm trying to reduce or produce the new set of features. Okay. So in feature extraction, we try to find a new set of features of less dimension through some function mapping, some mathematical function mapping. It is not same function. Okay. So some transformation is happening. Transformation. Like we have initially n feature, I've reduced the k dimension, which is quite less compared to these. But how we have done? We have passed through certain function which has transformed or changed the values. Okay, which is either linear combination, square, cube, and somewhat things by which we can reduce the density. This is what called features when we are doing some operation over original feature. Another thing is that the mapping of app could be linear and non-linear. You can apply non-linear mapping. You can use sigmoids, ReLU functions. ReLU is considered as piecewise linear, but other functions we can consider that which are non-linear function. So, like simple linear function, you can map with the sigmoid function, it will become non-linear. And there is feature selection, it is just subset selection. If you have a set with the n elements, the 2 raised by n number of subset is possible, and the choice is your how many features. So, but we are not changing any values. We are taking the same value, but with the few dimensions. In 1000 data, I am selecting only 20 and 50. A subset of the original features. Okay, no transformation. So that is what difference between feature extraction and feature selection. Now the feature extraction is coming. And most of you heard about the principal component analysis, linear discriminant analysis. Today I will give the intuition behind of these techniques of dimensity. So linear combination are particularly attractive because they are simpler to compute. Always the linear things, linear classification is very easy to visualize or computationally not that. We can analytically test, as I told that non-linear, maybe some exponential growth or something which are not analytically traceable. Numerically is different, but analytically I'm. The combination are particularly attractive because they are simpler to compute and analytically traceable. So now coming with example, the given set of X with the n dimension of data. The data set is given. We have column 1, column 2, column n dimension. So that's why I've considered the dimension is n. And we have maybe m number of samples, sample 1 to sample m, each having n dimension. And I need to reduce with the k dimension, C1 to Ck. The matrix which I'm generating is T for corresponding S1 to S2 samples. So earlier I was representing into n dimension, now I will represent into k dimension, which is quite low compared to. how it will happen with the linear combination. Okay, what possible things will happen. So you can see that the original function is t. The original data is x, which is going to multiply with the t, and I am transforming into y, which is quite less. Okay, so which is of k dimension, k is quite less. So this is just linear transformation from the k and x features. I am producing the ky features. So this is called projection of n dimension to k dimension, and this is what actually we refer as dimensionality. Later on, I will show the importance of dimensionality increase when you can apply the some kernel function. You can move from 2 dimension to 3 dimension or multi-dimension. It will help you to separate or visualize data very perfect. But in this case, I am trying to project n dimension data into k dimension. And for time being, I need now participation from the student or participant side. Maybe you are aware of correlation. We have two features, x1 and x2. To whom I will give weight, that will depend on later on. My data is distributed like this. With x1 and x2, my data is moving in this direction. Another data is moving like this. Your data can move like this. X-axis is representing x1. So anyone who is aware of correlation, what is correlation? Because I am considering 2 dimensions, x1 and x2. And I have different samples, maybe 100 samples I plotted by different. Very good. I have received the answer in the chat. So, but most it is preferable if you can speak audio also. There is positive, no correlation, very perfect. Chandra Kumar has replied nicely. So if you see that the first diagrams, it is like positive correlation. The value of x is increasing. The value of x2 is also increasing. Okay. Okay, fine. This one is positive. There is negative correlation in this diagram. If you see that. This one is negative correlation because x value is increasing, y is decreasing. Yes, positive correlation. Positive correlation. This is constant value. X is increasing, x is cost, x2 is increasing, but x1 is not affecting. Here x1 is increasing, but x2 is not affecting. If you see the distribution of data, this is the distribution of data. In this case, the x direction is neutral. Irrespective of any value of x2, x is constant. So x1 direction may be not playing any role. So if you projected this data over x1 and x2, let us see this is 2 dimension. I am projecting 1 dimension over this one. So if you see that the projection of this data, maybe in some other slides I will show, like you have projection of this data. The data is like this. So if you have to project this data over x1, what will happen? The data will have this kind of Gaussian curve. If you project x1, it will come very, very steep curve, single points, because most of the data is varying. You have very less variance. Variance is direction of x2 is less. Variance is more. This much is the spreadness of data around mean value. The mean value is this one. Around this, how much data is there that you can get by the standard deviation, and it is telling the variance also how much data is in. So if you project it, so from here, if variance is more, that means that dimension I will try to determine. That means that dimension is a significant role over my data. My data is changing over that dimension. That's why this dimension I will try to return in PCA principal component analysis. We try to find the variance, such a dimension, such a direction where maximum data is distributed. The direction where no data. Suppose you are visiting to doctor. Doctor have to analyze whether you are healthy or unhealthy, and they have recorded your temperature and your age. You see that age is not going to affect you, but your temperature is going to affect. That means the variance of your healthy and unhealthy towards this one is there. So any question up to this point? Okay. So I'm just already asking from participant. In this first diagram, this diagram, which direction you will keep x1, x2? Because here both are same. So both are is important. X1, the spreadness around x1 is this one. And in x2 is almost good. In this case, also similar case. Third case is what is happening around x2, the data is very skewed. But around x1, the data is so you can return the x1, maybe you can skip x2. So it is helping me to find the data which direction I will keep. There is various methodology by which you can exclude the dimension so that we can see that where. Here I am going to do this transformation. So this is what called projection of two-dimensional data into one dimension. Okay, then check the variance. So feature extraction from mathematical point of view, finding a optimal mapping y equal to x is equivalent to optimizing the objective criteria, objective functions. Okay. Objective criteria, we need to return such dimension where maximum data is. So different method used for objective criteria. So based on these two objective criteria, one is minimization of information, or if you are reducing particular dimension, you should not lose much data. The question is coming, you should not lose the generality of your model. Generality of model is that with minimum number of training, your model should be more robust. Okay. Representing the data as accurately as possible in the lower dimensions. Maximizing discriminating information. If it is classification, and I want to separate boundary between two classes, it should not that one category of data is merging with another category. The demarcation or boundary between two data should be very clear. The objective is that, suppose this is my cross, this is my plus. If you want to project over x1 direction and x2, so in x1, if you project, you will find these are the cross, and plus is also overwriting. You will not find any difference between plus, and both classes will have very less difference. But you will plot it over the x2 direction. So here you have clear boundary between plus and this one. So anyone who can answer this query, whether you will return x1 direction or x2 direction, because if you see here, the squareness around x1 direction is more of both the classes, plus and cross, but they are clearly separated in direction x2. Which direction you will return? X1 and x2. Please answer. So Sudha Abhiramani, can you hear me now? Is requested to increase the volume. So if she is able to answer me this way, I said also answer.
It is okay, sir. Your voice is good.
Okay, I can you please tell me why x2? As I told that I need to return the such direction where data is maximum squared. That means I should not lose the information such direction I'm keeping. If you are trying to go for x2 in this case, but second case I need maximum discriminating information so that class should be separate. वो डायरेक्शन रखिए जहां हम दोनों के बीच में डिफरेंस कर पाए. उसका मतलब क्या कि a प्लस ग्रेड और a प्लस दोनों ग्रेड साथ मिल जाए. A plus and A should be different boundary, separate boundary. So answer is correct, x2. That only things we'll see during this entire presentation. यही हमें देखना है. Yeah, please.
Sir, kindly somewhat audible, sir. It's
From
very
my
much low to me to hear
okay.
your
Maybe
voice.
you can check at your end. You can increase because I am speaking with the maximum volume. Okay.
Okay, sir. Thank you,
Okay.
sir.
Maybe it is problem at your end. Huh? Okay. Okay. Let us go ahead. So these two answers I will give this presentation. At the end of this presentation, you will be able to answer this query, and this is only the entire discussion of my presentation. Popular linear feature extraction techniques. These are principal component analysis. So I will not go in much mathematics or things. I will just give you the intuition of PCA. Seek a projection that preserve as much as information. As I was telling that we have to either preserve the information or discriminating information. So in PCA, I'm seeking the such direction where data is maximum varying, the direction where data is maximum distributed. So as in previous case, it was quite evident that the data around x-axis or y, maximum data is spread around x-axis. The curve will come like this. Spreadness is more. Around y very skewed. But the challenge is that y is discriminating information is more. So obviously I will go for more discriminating, which is giving me clear thinking. I never want to go such a solution which is very vague or very ambiguous kind of things. Those information is more what is the use of that information. I'm well equipped with the resources, thousands of books I have, but I'm unable to judge the decision. So the person with the very less knowledge but able to judge, okay, we'll just select that person who is able to answer this question, who is able to take this decision capability. So seeks a projection that preserves as much information in the data as possible. LDA, linear discriminatory analysis, it seeks to project the data with the best discriminant. So as per two objective, two mathematical famous techniques is written here, PC and LD, principal component analysis, which is trying to preserve as much as information, the data direction, and whereas second case, as I was telling to preserve the y direction, that is seek to project the best discriminating of the data. Both fails with some point of times that I will tell you. And some other techniques are also there which you can explore a little. Like independent component analysis, I see independent in all axes are independent. So making feature as independent as possible. There only redundancy of data should not be there because many times same features, two features can serve the same. Retaining the interesting direction, again, that is projection pursuit, where I'm trying to pursue the projection. So returning this one and embedded to lower dimension manifold, isomorphic locally linearly embedding and LLE techniques. So now let us represent the each data point in the vector representation. We have n dimension data. Each point will represent with the n dimension point in the sense sample or subject data. Okay. Assuming that the standard basis B1, B2, because who are aware of vector calculus or matrix, they must know that there is base vectors, okay, I plus j plus k, and 2i, 3i, j is there. So unit vectors of each direction, magnitude should be 1. So x can be obtained by the projecting x along direction. So suppose this is my x1 point. This value of x1 plus x2 and x3. We have three independent vector b1, b2. These are the basic vectors. If we multiply, we can map with respect to b1, b2, b3. These data. Okay, same thing I'm going to do, just multiplying the thing. So what I'm going to do, you have to normalize also value because the sum should be 1 of this root square. So each data point is multiplying with the new basis vector divided by the square of this one. X can be reconstructed from its projected epsilon. X equal to just linear combination of vector calculus. You can go for X transpose V In case of product, you can go x1, b1, x2, b2, x3, b2. So since the basic vector are same for all n dimensions in the basic, we typically represent as n component vector. This is the case you can understand here. My data is distributed like this. This is my original x-axis, x2. You see that the maximum data is spread around this direction, not around x-axis. Maximum data is distributed. So to transform there, what we do, we can subtract the mean value here. So the mean of all data sample will come here, mu1 and mu2, because this two direction. If you subtract from all sample, this x1 and x2 will shift to mu. If subtract the value of mu1 and mu2 from all data sample, this mean will shift here, and then with the basic vector you multiply, and it will tilt over that basic vector in which direction maximum data is there. So I'm looking for the basic vector of such direction in which data is maximum distributed, as I know that this diagonally distributed data is maximum spread dimension. For this, I need to calculate eigenvalues and corresponding eigenvector. Eigenvalue will give that value which will tell in which direction maximum data is we are getting spread, and then eigenvalue, each eigenvalue has corresponding eigenvector. Eigenvector will give the just direction, that is the vector around. Where vector can be represented by the n component x1 to x1. We are reconstructing, and basic vector here you can reconstruct with the n component. Similarly, you have k vector also. So just for example, I am giving one thing. You have vectors. Single point is 3 and 4. So two dimension data is there. So you can write 3i and 4j, where vector is I and j, 1, 0 and 0, 1. These are your basis vector. Okay, the basic vector is I and j. X can be obtained by projecting x along I and j. So the value will become 3i and 4j. 3i and 4j. X can be reconstructed from its projected. This is 3i and 4j. Now let us understand what is linearly separable data, what is non-linearly separable data, and what is the significance of this one. So if you see that this data, it is represented in two dimensions, x1 and x2, and there is okay. So maybe the data is not able to visualize here. There is two class. One is this plus plus plus. In two dimension, I can draw the single line decision boundary. So that we call linearly separable data. This is negative data. This is positive data. Whether in non-linear, what is happening? There is some positive classes are here. Some positive classes are here. So single line you cannot draw which can separate this minus red points from the positive green reds. You require some non-linear decision boundary. Okay, your operation is there. So this is called non-linearly separable data. So like you can take this example of function. We have linearly one dimension data, 1D data. If you take in 1D, I can draw only the dot at decision boundary. This could be dot, so this data is quite perfectly separate. But what is happening after some time, these four data is going to misclass. If we consider the decision boundary here, these last four will get misclassed. So this data is non-linearly separable in one dimension. Okay, so non-linearly data is a bit difficult to represent. You can see that you require such kind of decision boundary curve. In 1D, the curve cannot be plotted. So in 2D, I can project these data points in 2D. So the data can be become new. Maybe it is -8, -7, -6, -4, -3, -2, -1, 0, 1, 2. I will take x and x square, two things. X the value and x square. Then I will take 0 will remain 0 and 0 square 0, 0. -1 become -1 and 1 square 1. Okay, so you have featured now x and x square. So based on this, you can project the data from one dimension to two dimension, and data will become linearly separable. This point is 0, 0. This is 1 and 1, 1 square, -1 and 1. This is -2 and 2 square, 4, -3 square will be always positive. This is 2, 4, 3, 4. This will, and now you can easily draw the line in 2D. This is called concentric function or conjunction of features. Okay, so in this way you can separate the project the data in high dimension. Some basic example, decode the function. It is question to up to you. The first is quite obvious. In one dimension, the data is non-linearly separable. You require such a complex decision boundary. For projecting this one, again, I have taken x square function by which you can separate the data. In another example, what is happening? We have highly non-linear function in 1D like this. Even an odd number, even an odd number. What you can do, even number you can map with the 1 and odd number you can be -1. Easily you can get, you just divide by the this modulus 2. If you are getting 0, you map with the plus sample, otherwise negative. So these are the different functions by which you can decode. Now in machine learning, we have classification of things. And as I was talking about features, I'll come back on feature. So we have to differentiate between the tasks. You can see my screen. Okay. So what is happening? Suppose we have to take the person is in low risk or high risk. The bank person or they are checking your civil score and they have to give you loan. So if you are a high risk, I will not provide you the loan. If you are low risk, I will provide you the loan. So I'm checking two parameters, what is income and saving. You can say that both are important. If you have very much income is more, but saving is less, you are in high risk area. Income is less and saving is more, then also risk area, but income more and saving is more. Then you are in low risk area and easily bank will grant you the loan. In this case, you have to find the distance boundary. These are some examples. Okay, some application of classification machine like face recognition, character recognition, MINST data set is that means data, spam detection, genuine mail and spam mails, medical diagnosis where we used to find the symptom to illness, different sort of categories, biometrics, in recognition, authentication using physical and behavior characteristics like face, iris, signature, and gait. I'm working the gait analysis. That means human walking pattern, how human walking used to walk, such pattern we consider as behavior-based biometrics. Like physiological, you have face recognition, iris, and other sort of. Now coming on one basic difference between the important of feature I'm going to explain here. Those there is supervised learning classification. In supervised learning, each class sample I know the class level. So as we have two-dimensional data, x1 and x2, I know the class level y1, y2, y1, y2, maybe binary. We have given each sample x which is of k dimension or n dimension, but their label is associated y1, y2. To learn a function, such a function f, which can predict the y based on given x. So suppose we have one dimension data and we are just taking the tumor size. So if tumor size is big, we'll consider that it is malignant. If tumor size is very small, then we are turning in the benign. But this is not actual classification of benign and the malignant tumor size. Maybe tumor size is newly generated and its size is more, but age is less. So I have to classify this data, because as you can see that here single dot is not able to predict because some data you are going to misclassify. I have projected the data over this. If it is benign, I am categorizing it 0. If it is 1, I am categorizing malignant. So you can get the decision boundary better. But this is not exact representation. For this, what I have done, X could be multi-dimension where I consider the age also. ट्यूमर साइज है और कितना उसका एज हो चुका है, 1 साल हुआ है ट्यूमर साइज को 2 साल. You can see that as tumor size is growing and age is also growing, then we are considering it is malignant. Otherwise, if tumor size is big but its age is less, I'm still considering it as benign. That is good. That is better representation. So each dimension corresponds to an attribute. You can go for clump thickness, uniformity of the cell size, uniformity of cell space, other various features you can consider so that you can have better visualization. In unsupervised learning, we don't have any labels of the data, but based on their structure, their similarity patterns, by finding the distance between among different classes, we can segregate. So now I'm coming on this feature extraction techniques that you call principal component analysis (PC). And the PCA, in short, I can tell it is dimension reduction techniques, not classification, in which we try to reduce our data from n dimension to k dimension, and we try to select the k principal component or k principal vectors or direction in which data is maximum wherever, as we are trying to protect their information. We should not lose information. So we are not going to see the class discrimination. We are going to see that in which direction maximum data is separate. So if x is n dimension, then it can be written as the linear combination of orthogonal sets b1, b2, bn with this one using the standard basis. Orthogonal is there as I know that a dot b equal to modulus of a modulus of b cos theta. So if modulus of a is 1 cos theta, cos 0 is 0. Sorry, cos 0 is 1 and cos 90 is 0. So if orthogonal vector I and j, their dot product will be 0. If they are I dot I, then this is 1. So then you can normalize the value also. If it is not coming between 0 to 1, then you have to normalize. So PCA seeks to approximate X in a subspace of Rn using a new set of A basis vector B1, B2 in Rn, where my objective that earlier data X and X task cap. That means reduce data, the difference between is minimize the information should not less minimize information. And we have reconstructed over a new set of basis vector when you to you. The optimal set of vector U1, U2 can be found as so how you can calculate this optimal set of new vectors in which you are projecting your data X now in X bar. So first you have to prepare the covariance matrix, and there is variance which is telling splitting. Covariance matrix is always square matrix. You have X, Y, Z, three features X, Y, Z. You have X, Y, Z. You take this is XX, this is X, Y, Y, this is Z, Z, this is X, Y, this is X, Z, this is ZX, YX, YY, and YZ. This is ZX, ZY. So diagonal is always variance. You are going to see how you are different from yourself, X and X. But when you are going to see XY and YX, both are same thing. How X is related to Y, how Y is related. So upper diagonal, lower diagonal, you will get same matrix. So this is what covariance matrix. So and after finding the covariance, the significance of different direction, how they are correlated with each other. Okay, and then you have to compute the eigen values. Okay, so you will get some eigenvalues, some of them will be 0. So first eigenvalue will consider, keep in decreasing order, try to keep the highest eigenvalues, because we know that corresponding highest eigenvalues, you will have more information, and then select these eigenvectors, and then eigenvector U1, U2 will be your new set of optimal set of vectors in the subspace. Choose the k largest eigenvector ui corresponding to k largest eigenvalues theta. These are the optimal basis. Once we have optimal basis, just project your data over these points. We refer the largest eigenvalue ui as the principal component. You can have multiple principal component 1, 2, 3, 4, 5, 6. So the PCA steps is again, suppose we have some data x1 to x1 of n dimension. Okay, n is the number of features, m is dimension, and each data is of n dimension. So you have S cross n matrix, compute the sample mean, it is like that. So x1 is of 2 dimension, x2 is also of 2 dimension. Dimension consider d1 and d2, let us write d1 and d2. Here n is equal to 2, number of feature is d1, d2, m is number of sample is 10. Okay. So how it is happening? We have x1, x2, x3 up to x10. Okay, 10 samples, x1 to x10. And each is having 2 dimensions, that means d1, d2. D1, D2, D1, D2, BPN temperature, BPN temperature. So for this, I will compute first mean, so that what will happen, as I earlier also discussed these things. Suppose data is distributed like this. If you find the mean of all samples, this is x1, x2, you will find somewhere it is mean in between. This is mu1 and mu2, 2-dimensional. You find the mean, subtract the mean. So if you subtract the mean, this principal axis will shift from here to here. This T1 and D2 will go here. So this should be always 0. There will have mean at 0, 0 points. Okay. All negative sample are below this one. Once mean is here, compute the variance. Once we have variance, then variance is just, you can compute by this formula of each points. The point is like what is how we are calculating the covariance. Okay, the covariance you can check like this. We have 2 dimensions, D1 and D2, and m samples, x1, or let us represent by dot. Okay, 10 samples, because I am considering m equal to 10 and dimension is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ram, Sita, Gita, Vita. These are the samples. Each I'm considering what is their height and weight. Let us consider. If I calculate the mean, so mean of group mean. There is sample mean and group mean. This you consider as a sample, because S1 to S10 is sample. It is not entire data set. In the batch normalization, other way you used to select a particular sample of data. Entire set of data you cannot. This is sample mean. Sample mean will come mu1 and mu2. If you subtract all data points, this is suppose mu1 mu2. If you subtract minus mu1 and mu2, it will become 0, 0. The center will become 0, 0. And then this point will shift here. This point will come negative samples. This kind is positive sides. Okay, we have subtracted. Suppose earlier it was 4 and 3 with respect to this one. With respect to this one, it will become minus 0 and minus 3, because you are subtracting your mean values. Okay, it is coming negative sides of this. Once a mean is subtracted, then what is your observation? Because my observation should be like this way. I'm just giving you intuition. I know that maximum data is distributed in this direction. First, you subtract the mean, shift this coordinate system from here to here. After that, rotate this one around this one. And this is your get highest eigenvalue in this direction. So for this, you have to find the covariance of x1, x2. I need to check in which direction maximum data is spread, because the PC is working on the thing concept to compute the sample variance, that is sigma x, and it will be always square. If it is 3-dimensional, you will get 3 cross 3, in which diagonal is variance, and off diagonal upper or lower will be variance, like xx, yy, zz, and xy, xz, yz, or below is yx, zx, zy. So x is y is same value y, because how x is related to y, it is like that. How x is changing to y. How, if I'm doing a study 9 hours, whether my grade is increasing or not. How they are related, whether they are related or not. If I'm eating more, whether my grade is suffering, is released. Such kind of things we can find with 2 different variables. Okay, if my height is increasing, so my intellectual is increasing, or my weight is increasing, somewhat correlation we attend. So we'll check these values. Once covariance is that, this is square matrix, and we know that we can find the inverse of any matrix if it is square, and its determinant should not be 0. If determinant is 0, then it will become the singular matrix. For this, we cannot find the inverse. So this is some 1 upon m. Each point you subtract the value of mean and take the transpose. This is how covariance matrix you can find. In MATLAB and Python, already formula is there. You just pass your matrix over there. It will return you covariance square matrix. Once you have computed the covariance matrix, then we know that we have to compute lambda y, so a minus lambda I x equal to 0. Then you will find the eigenvalue and eigenvector. This is same formula is here. Okay. And eigenvalue, the important eigenvalues. The eigenvector will tell nothing. It will tell just magnitude. Suppose this vector is lambda. It will calculate eigenvector 2 lambda. It will return such direction, but it will augment your values. Okay, so that is what eigenvalue is doing. So it can perform the rotation as well as transformation. Because original axis was like this. Original axis was like this. I need to shift axis in this direction. And then I need to see x direction maximum data is separated, y direction less, so I will return only x direction. Because I will get maximum value of eigen in x direction. Then we'll decreasing order. If we are getting 10 eigenvalues, 10 principal axis you are getting, or k principal axis, you will return only k ratio. So most software packages return the eigenvalue corresponding eigenvector in the decreasing order. If not that, then you have to keep manually or write the program to keep it. Yes, you are orthogonals here. And last step, once you have reduced your eigenvalues, eigenvector, you have to project your original data over these new k principal direction or principal features. Okay? Then you have to project all the data. What is linear transformation implied by the PC? Okay, already I told you everything. So I'm not going this mathematics. Interpretation of PCA now, this is important. And then I will take another 5 to 10 minutes and we'll finish my session here. With the LDA, I will come here. So PCA choose 1 minute. Sorry for interrupt. Now let us see the interpretation of PC. What PC is doing all about. So I was showing that PCA choose the eigen vectors of the covariance matrix, and we used to select the largest eigenvalue. Corresponding largest eigenvalue, it will give you like this. Suppose you have matrix A, sorry, AX equal to lambda x. So what is happening? The matrix A, the eigenvalue matrix A is just the vector is 1, 2, 3. It will multiply 3 times of 1, 2, 3. So what eigenvalue is doing, it is not transforming or changing, it is just multiplying with the sum factors we are getting. Okay. So lambda is 3, minus 2, minus 3. So scaling is doing. Scaling is doing in this direction. Suppose my vector in this direction, it will get scale. Okay, it will. So we have k eigenvalues. Lambda 1, lambda 2, lambda. It will be diagonal values. Rest of diagonal will 0. These are eigenvalue. Corresponding each eigenvalue will have vectors like this is lambda 1, this is lambda 2, this is lambda 3. So this is vector 1, vector 2, vector 3. You select only those lambda values which is positive, because negative eigenvalue you will not find. These are positive and non-zero. And if you require or we require only 10 eigenvalues, select the top 10 eigenvalues corresponding to 9. Okay, and what eigenvalue is representing, already I told that it will represent that such direction with variance is much, where the spanness of data is much, where the loss of information is less, the data along with the eigenvector. Therefore, PCA project the data along the direction where data varies most, as I told that initially this one. So PCA preserves as much information as data by presenting as much variance. So you can see that initially I have x1, x2, We have taken the mean x bar, then we have subtracted the mean, prepare the covariance matrix, calculate the eigenvalue, eigenvector. Finally, we got mu1 and mu2. So mu1 is the direction of max variance, mu2 is orthogonal to mu. You can take some example, 1, 2, 2 dimension data is there, 5 points there, take the mean, subtract the mean of this sample. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 values there. So you divide 1 plus 3 plus 3 plus 5 plus 5 plus 6 plus 8 plus 9 divided by 8. Similarly, y point, that will you get mu1, mu2, subtract the sample from mu1, mu2, calculate the covariance matrix, then eigenvalues, eigenvectors. ठीक है, तो आपको ऐसी डायरेक्शन मिल जाएगी v1, v2, which you can go. Now the question is coming, how we are choosing the k. K is the number of value. K is typically choose where how much information we want to feature. To choose the smallest k, satisfy the following inequality. So what is happening? The sum of all the eigenvalues theta 1, theta 2, and divide by the sum of the selected k values divided by n if it is greater than 1. Okay, so we are not significantly losing the things or threshold. It is the threshold. If threshold is 90% mean 0.9, so we will preserve the 90% of eigenvalue. If it is 10, then I'm t equal to 0, for example, we preserve 90% of information in the data. If k equal to n, we preserve 100% of information, no changes, and then we reconstruct the error with this. Data normalization, I'm not going. I'm coming on another popular techniques, that is LDA. With this, I will finish also my talk. I will show you the problem with the data. The popular application is face recognition, which I'm not going to explore. Now the limitation of PC I will tell, and then we'll move to LD. I will not give mathematics detail of LD. So PC is not always an optimal density reduction techniques for classification. The reason is that anyone who can answer that, which direction your data is maximum is varying, x1 and x2. Which direction data is maximum varying? Please answer. Which direction maximum data is varying? x1 or x2? कौन सी direction में data you can write in chat box or either you can participate. The data is maximum spread around, correct? Vaishnavi also written and x1 and Amarnath also written. Okay, so that is we consider as principal direction as per PCA. As I told that PCA will preserve that direction in which maximum data is spread, correct? So which direction is better? X1 is better or X2 better? For which? X1 is okay. The variation is more data. I know that this data is representing this one, and another class is, and you see that this much of data is overlapping between class 1 and 2. Okay, so Daulat Singh, can you give me answer? X1 direction is better or X2 in sense of classification? डेटा को क्लासिफाई करना तो x1 को रखोगे या x2 में देखिए वेरिएशन तो कम है, डेटा बहुत ज्यादा स्प्रेड नहीं है, स्मॉल डेटा स्प्रेड है, बट इनके बीच बाउंड्री क्लियर है. यहाँ पे बाउंड्री नहीं, इतना मच डेटा ओवरलैप हो चुका है. दिस डेटा यू कैन नॉट मैप दिस. व्हिच डायरेक्शन यू विल प्रेफर, x1 and x2, and why? X1 is principal component analysis, PCA will give this direction, and according to PCA, x2 is my. Chandan has answered that x2 I will preserve because I need to check the dimension where maximum data is spread. So PC is not optimal because they used to work on the data variance. They are not considering the distinguishedness of the data, the discriminating power. Okay. So for this LDA is there. The LDA seeks to find such a direction, such a best direction in which the data is best discriminating, increase the discriminating. So for this, we'll check the within class discrimination and between class. Between class discrimination, we want maximum, and within class, we want minimum. So we'll design some objective. If it's a discriminating function that I'm not going to tell you. Just see that. Which one is better? Figure 1 or figure 2? And why? Can you see my PPT now? Okay, so which one is better? Figure 1 ज़्यादा better है figure 2? कौन सा data ज़्यादा separate दिख रहा है? If you figure 2 देखिए, figure 2 बिल्कुल the reason is that Kalpana has answered that ये data यहाँ पे aggregate है, ये data यहाँ पे aggregate है, clear difference bounding. So the direction is this I will consider because the data is maximum discriminating information. But in figure 1, what is happening? Some blue as well as red is going to perfect answer. Okay, so from here this is clear that why LD is prefer over PCA. Well, if data is working based on the separatability of their variance, then we go for PC. And if we will see the maximum discriminating analysis, we will go for LD. So this was all about my presentation. I think that I've done with my presentation. If any more information is left, I will cover with you. This is the techniques I'm not going to explore right now. You can see the example also. Scatter plot of PC and LD. You can see that two positive classes you see. This is my positive class. This is my positive class data. This is my negative class data. Okay, PC is giving this direction where both are not linearly separate, but LD is giving this principal axis. And you can see that in principal axis, you can find the clear difference between class red and blue. You can see that LD is giving quite clear direction with respect to PC. Okay, with this, I will finish my presentation here and I will open my session for question answer. If you have any question answer, you please feel free to ask question. Any question answer.
Thank you, sir. Is there any question from participant side? If there is any question, then you may send your question on the chat box or you may ask. Is there any question? Sir, one question from one participant from the Ruby is one of the participants. He is asking if PCA and LDA applicable in microbiology research.
Yes, if data is like genome sequence and numerical data is there, that time it will work. Even textual data we are using, but numerical data you can apply. I've seen that when gene sequence we are trying to find between different category of classification, that time it can work.
Okay. Any other participant? Okay, fine. I think, sir, machine learning, it is a technique which we can apply in any field because machine learning, it is currently it is a very vast area and we can apply in any field. Currently, in the new education policy, the government focusing on interdisciplinary. So I think the machine learning AI, it is a technique which we can applicable in any branch of the education. Okay, like linguistic, we can apply for text processing and other. Thank you very much, sir. So actually, sir, Pawan sir, at present, there is some important work, so he is not there. So I'll just present a vote of thanks on behalf of Department of Computer Science, Indira Gandhi National Tribal University. I, Dr. Abhishek Bansal, who's proposed a vote of thanks to Professor Vijay Bhaskar Sambalji. Sir, you have discussed a very important topic of principal component analysis, which generally we use for the dimensional reduction of the large data set. You also discussed the interpretation of PCA, data normalization, limitation of PCA. So the lecture is very good. I once again thank you very much to deliver this nice lecture. Thank you very much.
Thank you, Abhishek, sir. Thank you.
Thank you, sir. So next time when we organize some more conference, so I'll just invite you.
Okay, sir. Sure, sir. Thank you. It is my pleasure.
Thank you very much. Okay, fine, participant. Tomorrow we will just start with the next session from 10 o'clock. Is there any query? From the participant side, is there any query? Okay, we will find the PPT from the resource person and we will share on the Telegram channel or I also sent the email. Okay, thank you.